There is a star in our galaxy that should not exist. Its age, if we dare to trust it, stretches beyond the time the universe itself is supposed to have had to grow. Its light does not scream. It does not flare or demand attention. It hangs there in the quiet of the sky, a pale dot among countless others, as if it were nothing more than another distant sun. But buried inside that light is a story that does not fit. It is as if you opened a book about the beginning of everything, and hidden between the first pages, you found a sentence written long before the book was even printed. Tonight, as you lie there, eyes heavy, breathing slow, imagine a single photon leaving that star a very long time ago. Imagine it squeezing past cold dust and drifting gas, slipping under the soft gravity of ancient clouds, weaving through spiral arms and stellar winds, until eventually it finds your small world, your quiet room, and the thin surface of your eye. That photon carries a message. It says, very softly, something here is older than it should be. You are listening to Whispers of the Universe. If you are kind enough to keep this quiet corner of the cosmos alive, let your presence leave a trace. Gently like this video, share this whisper with someone who dreams beneath the same sky, and subscribe so the next journey can find you when night returns. The story of this impossible star begins, as every stellar story does, with its light. Astronomers do not touch stars. They do not fly to them or bring back pieces to hold in their hands. They read them the way you might read a candle flame through tinted glass. The color, the subtle shifts in brightness, the thin dark lines in a spectrum. All of these are syllables in a language written by physics and spoken by light. When this star was first studied in detail, it looked old in the way a weathered face looks old. The pattern of elements in its atmosphere was astonishingly simple. Very little iron, very little of the heavy metals that younger generations of stars carry like jewelry from older explosions. It was almost pure hydrogen and helium, with just the faintest dusting of heavier atoms. Stars like that belong to the early universe, to a time when very few cycles of birth and death had yet enriched the cosmic gas. But there was something even stranger buried in its glow. By measuring how bright it appeared and combining that with how far away it was, astronomers could place it on what they call the ladder of stellar life. On that ladder, young stars sit here, middle-aged stars sit there, and ancient stars lean near the edge, their fuel nearly gone. This one stood near the top of the ladder, as if it had been burning patiently for almost as long as stars have been allowed to exist. The first time its age was calculated in detail, the number that came out was not just old, it was older than the universe itself, according to the best models of cosmic history at that time, not by a small, comfortable margin that could be brushed away as a rounding error, but by enough to make people stop, look again, and feel something cold and delicate in the back of their minds. A star cannot form before the space it lives in. A candle cannot burn before the match is struck. And yet, here was a star whose calculated age seemed to whisper that it had. In science, when something does not fit, the first suspicion is not the universe, it is us, our methods, our instruments, our assumptions. The star did not move. It did not change its story. So the people watching it did what humans always do when reality pushes back. They began to ask if they were the ones holding the ruler wrong. They turned again to its light. They measured its distance more carefully, using the tiny shift in position that comes as Earth swings around the sun, an elegant triangulation written into the geometry of the sky. If the star was closer than they thought, it might not be as bright as they believed. If it was not as bright, it might not be as old. Bit by bit, they refined their estimates, feeding better distances into their models. They looked again at its spectrum, at the thin, dark notches where certain colors were missing. Those missing colors tell you which atoms are floating in the star's outer layers. Each element leaves a signature like a fingerprint. The pattern here was clear. Very low metallicity, as astronomers call it. That meant the star must have formed early, when the universe had not yet been seeded with many heavy elements from previous generations of supernovae. Early formation meant an ancient age. That part of the story refused to budge. They adjusted the physical models that describe how such a low-metal star evolves. They asked whether the physics of how hydrogen fuses into helium in this kind of star might yield a slightly different lifetime than they had assumed. They checked and rechecked the sensitivity of their equations, peered into the uncertainties, and watched how the estimated age slid up and down as they pushed and pulled on every parameter that would still make sense. Each time they made the measurements more precise, each time they tried to tighten their grip on the star, the same strange truth returned. No matter how they bent and twisted their calculations within reasonable bounds, its age drifted stubbornly to the very limit of what the universe's own age would allow. In some calculations, it stepped just beyond, as if one sand grain had slipped through the cosmic hourglass before the hourglass was even turned. There is a particular kind of silence that falls in a room when numbers line up in a way no one expected. It is not the silence of ignorance. It is the silence of a door half open. People spoke softly about systematic errors, about underestimates of uncertainty, about hidden biases in the data. They pointed to the possible errors in the age of the universe itself, which is inferred from the glow of the phode, cosmic microwave background, from the expansion rate of space, and from models that stitch together a tapestry of observations into a single history. If the universe were a little older than they thought, the star could be forgiven. If the star were a little younger than they thought, the universe would not have to bend. Somewhere between those two shifts lay a narrow corridor where everything could be reconciled again, where the story would be smooth and human and safe. But the star did not step aside to make room. It remained an outlier, a quiet spike in the graph, a single data point that sat apart from the comfortable cloud of others. Most stars fit beautifully into the models. They traced out the expected patterns on the diagrams, their ages and compositions singing in harmony with the story of a universe that began in a hot, dense state and cooled and expanded over time. Only this one star seemed to sing a different note. Imagine standing at the edge of a dark lake at night, throwing pebbles into the water and watching the ripples. After a while, you come to know how the ripples behave, how quickly they fade, how they overlap and smooth out. Then one evening you toss a small stone, and the water answers with a wave that does not fade when it should, a wave that seems to remember the throw far longer than the rest. Everything you know about water tells you that this should not happen. Yet there it is, a moving line of brightness in the dark. The star is that unending wave. It is a reminder that our understanding, no matter how wide, is still only a shoreline. As the years went by and telescopes grew sharper, the star's position and brightness were pinned down with greater care. New space observatories refined the measurement of its distance. Ground-based instruments traced its motion through the galaxy, mapping out the arc of its path like a slowly drawn line on a forgotten map. Each improvement in observation trimmed away one more excuse, one more place where a comforting error might have hidden. What remained was a simple and unsettling picture. This star had formed very early, from material that had seen almost no prior enrichment. It had burned quietly for almost the entire lifetime available to any star, and it had managed to survive to the present day without exhausting its fuel or tearing itself apart. Its existence pressed against the limits we had placed upon the age of all things. Lying there in the dark, you might wonder why any of this matters. A star is old, perhaps a little older than it should be. Why should that disturb your sleep or the vast indifference of the night outside your window? It matters because age is not just a number written in a column in a data table. Age is woven into how we think about beginnings and endings. The age of the universe sets the frame for every origin story we tell, from galaxies and stars down to planets and the fragile possibility of life. If a single star truly stands outside that frame, then either the frame is drawn wrong or the story inside it is missing chapters. And so, in quiet offices and late-night observatories, people kept returning to this star. They compared it against models of stellar evolution, against simulations of early galaxy formation, against the limits imposed by the faint afterglow of the Big Bang. Each time, the same fragile unease settled over the calculations. This star did not just sit at the edge of what was allowed. It perched there, swinging 1 foot calmly over the void. The universe, as far as we can tell, does not play favorites. It does not place one special object in the sky purely to tease a small species on a small world. But it does something more subtle. It leaves anomalies scattered like pebbles along the path, small irregularities that catch our attention and force us to look again, to refine, to question, to admit that our current picture is not final. In that sense, the star that should not exist is less a mistake and more a mirror. It reflects not an error in nature, but the limits of our vision. Its impossible age is a quiet finger pointing towards something not yet understood, a small, steady light shining on the edges of our ignorance. As your breathing slows and the room around you softens, imagine the galaxy as a great, dim cathedral of stars. Most of its candles burn with an age and color that makes sense inside the scriptures we have written for them. But somewhere, off to one side, there is a candle whose wax is almost entirely gone, whose flame still stands straight and calm, and whose presence suggests the building has been here longer than any of our records say. We do not yet know whether our dates are wrong, or our architecture is incomplete, or there is some quiet trick in the physics of flame that we have not accounted for. We only know that the candle is real, that its light reaches us, and that it will not be ignored. The star that should not exist continues to shine. It does not hurry. It does not explain itself. It simply holds its place in the sky, its ancient photons washing over our instruments, our eyes, our doubts, and our dreams. And somewhere, beneath the noise of equations and models and debates, the universe seems to hold its breath, waiting to see whether we will choose to look away from this one small contradiction or follow it into the deeper dark where new stories begin. But the quiet breath the universe holds does not last forever, because when something in the dark refuses to fit, our eyes eventually turn back to it, drawn the way a tide is drawn toward the moon. The impossibly old star hangs there, unchanging, as if daring us to understand it. And so, slowly, patiently, we return to its light. For all the questions that have been raised, for all the doubt and discomfort its age has carved into the story of cosmic history, the greatest truth remains the simplest one. Everything we know about this star begins with a few thin streams of ancient photons. Photons do not age the way matter does. They carry no wrinkles, no scars from the years they have traveled. A photon that leaves a star and crosses the galaxy arrives at your eye with the same energy it carried when it began its journey, unless space itself has stretched it. That endurance makes light a perfect storyteller, but it also makes it an uncompromising one. You cannot ask light to smooth its edges or soften its contradictions. Light tells the truth, whether we are ready for it or not. When astronomers followed the trail of photons back to this star, they found a signature unlike the light of most suns around us. In the spectrum, the dark gaps where atoms swallow specific colors of light were arranged with a kind of elegant simplicity. There was hydrogen, of course. There was helium. But the heavier elements, the ones born in the violent deaths of other stars, were scarce. Iron was almost absent. Oxygen was faint. Magnesium barely whispered. This was a child of the early universe, a star formed when the cosmic material had not yet been enriched by many generations of explosions. That alone would make it ancient. But the story did not stop there. The quality of the light, the precise balance between brightness and distance, placed the star in a specific phase of its life. It was a subgiant, no longer young but not yet collapsing. Subgiants tell time with their luminosity. As they burn through hydrogen in their cores, their outer layers swell slightly, their brightness climbs, and the point they occupy on the stellar diagram shifts upward. This star sat high on that branch, too high, higher than any star with its composition should sit, higher than a star could reasonably climb within the age allowed by the universe itself. Still, scientists approached the problem with patience. If the star was sending a message, they wanted to be sure they could read it clearly. They began to refine their techniques, peeling away layers of uncertainty like old wallpaper. They started with the distance, because distance is the backbone of every stellar measure. Imagine you hold a candle at arm's length. It looks bright. You take 2 steps back, and the candle looks dimmer. The farther away it sits, the fainter it seems. If you misjudge your position in the room, you might misjudge the brightness of the candle. And if you misjudge its brightness, you might misjudge its age. Fortunately, the star was close enough that its distance could be measured with exquisite precision. As Earth orbited the Sun, the star shifted ever so slightly against the background, like a bead sliding along a thread. This subtle wobble, this parallax, allowed astronomers to pinpoint the star's location with accuracy far surpassing earlier generations. When the new distance was fed into the star's age models, something remarkable happened. The age estimate shifted downward, but not enough to relieve the strain. Instead of standing clearly older than the universe, the star now brushed so close to the cosmic age limit that the unease remained. Imagine holding a key that should not open a door, only to find that the key fits the lock so tightly it scrapes metal. It does not turn the bolt cleanly, but it sits there, mocking the shape of the door. The star's metallicity was the next clue examined. In astronomy, metallicity does not mean metal in the everyday sense. It means any element heavier than hydrogen and helium. The universe began with mostly hydrogen, some helium, and only sparse traces of lithium. All heavier elements were forged later, in stars that lived and died long before this star was born. The lower the metallicity, the fewer such stars had existed when this one formed. Low metallicity stars are windows into a simpler time, a time when the universe was young and order had barely begun to emerge. The spectral analysis here showed an astonishing deficit of heavy elements. It was as if the star had condensed from near primordial gas, untouched by the typical cycles of galactic recycling. That should have meant great age. But the way the star had evolved, the luminosity it now possessed, the position it occupied on the life ladder, these things suggested it had been burning steadily for almost the entire span of cosmic history. And so researchers returned again to the light. They studied the star's oscillations, tiny ripples on its surface caused by the way energy travels through its interior. These ripples create subtle shifts that can reveal the density, the temperature, and the structure within the star. By listening to its faint stellar heartbeat, astronomers could build a portrait of how its fusion processes had evolved over time. What they found reinforced the same quiet truth. The interior looked old. The envelope looked old. The chemical fingerprint looked old. Everything lined up in a way that said, gently but firmly, that this star had been shining for longer than it should have been allowed to shine. But there was always the possibility of error. Science is not brittle. It bends before it breaks. With each observation, each refinement, each improvement in calibration, astronomers hoped the numbers would ease the contradiction. Perhaps the star was misclassified. Perhaps the metallicity estimate had been skewed by some subtle effect in the instruments. Perhaps the models for subgiant evolution were slightly off, built on assumptions that applied well to most stars, but not to this one. Extreme cases test the rule. Sometimes the rule holds. Sometimes it shatters. With this star, the rule cracked, but did not fully break. Its age estimates shifted just slightly downward as observations improved, drifting like a leaf on a pond pushed by a soft breeze. But every time the leaf approached a comfortable middle place, it drifted back to the edge. to an age nearly equal to the age of the universe, an age that fit so tightly against the cosmic limit it felt like a challenge. Lying in the quiet of your room, you may imagine this star as a traveler who arrived at a feast early. The chairs were not arranged, the candles were not lit, and yet the traveler sat down, waiting patiently for time to catch up. The universe grew around it. Galaxies formed, spun, and merged. Stars lived and died in spectacular bursts of violence. But the traveler remained, steady and ancient, as though it had settled at the table before the feast had even begun. This is the strangeness that pulls astronomers back again and again. The star is not simply old. It is orderly. It is calm. It fits into the universe too well to be dismissed as an error. And yet its age presses against the boundary we believe defines the universe itself. There is something alluring about a contradiction that refuses to move. It feels like a knot in the fabric of understanding, and knots invite fingers. Astronomers began to tug carefully at the threads. They looked at similar stars, other subgiants with low metallicity, to see if they too nudged the upper limits of cosmic time. Some did lean close, but none leaned quite as far. None held their position with such stubborn confidence. It was as if this star alone had found a loophole in the rules and slid quietly through it. They then explored the star's motion through the galaxy. A star's orbit can reveal a great deal about its birth. Old stars often move differently than young stars. They travel on long, looping paths that cut above and below the galactic plane, traces of early chaos when the Milky Way was still gathering its shape. This star indeed followed such a path, sweeping high through the galactic halo, as if it were a relic displaced from some forgotten stream of early formation. And yet, even that did not explain its impossible age. Nothing explained it. Not its brightness, not its distance, not its chemistry, not its motion, not the models of how stars evolve, not the models of how the universe ages. Everything lined up except the most important detail. And so the star remained suspended between two possibilities. Either the star was older than the universe, an absurd conclusion, but one that the earliest calculations seemed to imply, or the universe was older than we thought, a conclusion that would force adjustments to one of the pillars of modern cosmology. Most astronomers chose a third path, the one science always walks before abandoning a theory. They assumed there was an error somewhere they had not yet uncovered. Perhaps helium diffusion in the star's outer layers was slightly misunderstood. Perhaps convection worked differently in metal-poor stars. Perhaps opacity tables were subtly flawed. Perhaps the early calibration of the cosmic microwave background underestimated the age of the universe by a whisper. But each time a whisper was corrected, the contradiction remained. The star still sang its quiet song of defiance. As your breath evens out, as darkness gathers softly around you, imagine each photon that reaches us from this star as a small bead, sliding along a string that stretches across cosmic history. Each bead carries a piece of truth. Each bead whispers, "The universe is very old, and so am I." But only one of us is telling the full story. For now, that story remains incomplete. Not because the universe hides it maliciously, but because we have not yet learned how to listen. And so we return, again and again, to the faint message carried in those ancient beams of light. We return because this star is not simply a puzzle. It is an opportunity, a gentle invitation to look again at the assumptions we hold, to question the boundaries we draw around time, to open ourselves to the possibility that the universe is not yet fully mapped. The star that should not exist continues to glow, softly, calmly, with an age that presses against cosmic limits like a fingertip against frosted glass. It waits for our instruments, for our models, for our humility, for our willingness to admit that, even now, after centuries of observation, we still stand at the foothills of understanding. And as we listen more carefully, the quiet whisper of its ancient light grows steadier, guiding us toward the next question the universe wants to ask. And that question lies just ahead, waiting in the next drift of darkness. The quiet message carried by that ancient light does not loosen its grip. If anything, the closer we look, the more insistently it calls us back, like a soft echo repeating itself in a place where echoes are not supposed to exist. The star does not flare or darken or change its tone. It simply remains patient and unwavering, as if waiting for us to understand what it has been trying to say all along. To follow that message, we return once more to its light, not as spectators, but as listeners. There is a kind of humility required when studying something older than your entire cosmic story. You do not rush. You do not demand. You let the star speak, and you hope you are quiet enough to hear it. Imagine drifting through a sea of darkness, where only thin ribbons of starlight guide your way. Each ribbon is a thread of memory, crossing your path from a time long before your world existed. Among those threads, one stands out not because it is brighter, but because it is steady, ancient, unbending. And the closer you drift toward it, the deeper its story becomes. The age of a star is not written on its surface. There are no numbers carved into its glow. Instead, its age lives in the delicate balance between temperature and brightness, in the ratio of elements inside it, in the subtle trembling of its outer layers as energy moves from the core to the edge. If you want to know how long it has lived, you must learn to read those delicate signs with the same attention you would give to a whisper spoken in a quiet room. The star that should not exist has been read again and again through different instruments, different methods, different generations of astronomers. Each reading has its uncertainties, its small mistakes folded into the data like wrinkles beneath the fabric. But the overall picture has remained the same, no matter how many times the fabric is smoothed. Its metallicity, the scarcity of heavy elements, reveals a birth in an era so early that the universe had barely begun to enrich itself. The first generations of stars had exploded, yes, but not many. Heavy elements like iron and magnesium had just begun to seed the gas clouds drifting between newborn galaxies. A star formed from such material would be exceptionally old, its life beginning when the universe was still learning how to build complexities out of simplicity. And so, when this star's spectrum revealed an almost primordial purity, astronomers nodded. That part made sense. Its chemical fingerprint matched the identity of a relic from the dawn. But when they examined its brightness and temperature, when they placed the star on the evolutionary path that all stars follow, the story bent in a way that did not match the expected script. The star was too far along. It glowed too brightly for its composition. It rested too high on the ladder where subgiants climb as they exhaust their hydrogen fuel. Everything about its position suggested that it had been burning quietly for nearly the entire duration the universe makes available to any star. And so the contradiction formed. The composition said the star was born early. The brightness said it had aged long. And when the estimated age was compared with the calculated age of the universe, the two timelines pressed against each other so tightly it was hard to tell which one was giving way. Some argued that the star must have been measured incorrectly. Distance is always the first place to look for a mistake, because brightness depends on distance, like breath depends on oxygen. A star that is closer than you think will appear brighter than it actually is, and a star that appears brighter than it is will appear older than it is. But in this case, the distance had been measured with remarkable precision, refined by modern instruments, designed specifically to chart the positions of nearby stars. There was very little room left for the kind of error that could hide decades or centuries of stellar age. Others argued that the models for subgiant evolution might be subtly flawed. Perhaps low metallicity stars evolve differently than expected. Perhaps convection carries energy upward in a slightly different way. Perhaps nuclear processes in the core proceed with a tempo we have not fully captured. These questions were not unreasonable. But every attempt to tweak the models stretched them in ways that felt artificial, like adjusting the tint on a photograph until the colors no longer match reality. And throughout all of this, the star remained unchanged. Its light did not shift. Its signature did not soften. Its age estimate continued to hover near the cosmic boundary, like a traveler standing at the edge of a map, pointing to a place that the cartographers forgot to draw. What makes the star so unsettling is not simply that it appears old. It is the precision with which its age approaches the limit. If it were far older than the universe, it could be dismissed as a clear mistake. If it were comfortably younger, it would settle into the pattern carved by every other ancient star in the galaxy. But instead, it rests on the boundary line, tracing the edge of possibility with a confidence that feels intentional. Picture a river that has carved its way through rock for ages. Most stones along the riverbank are smoothed in familiar ways, their surfaces shaped by uniform flows. But once in a great while, you find a stone whose edges are worn in a pattern that does not match the rest. You turn it in your hand. You study it. It suggests something about the river's past that you did not previously know. Another current, another force, another shape the water once took. The stone is not wrong. It is simply telling a story you had not imagined. This impossible star is that stone. It tells a story about the early universe that does not align with the story we have written. Perhaps the first stars formed earlier than we expect. Perhaps the gas clouds of the early universe cooled faster, collapsed quicker, or carried subtleties we have not yet modeled. Perhaps the physics of low metallicity fusion contains a nuance that shifts ages by amounts small enough to escape easy detection, yet significant enough to push a star like this one to the very edge of time. The possibilities are many, and that is what makes the mystery so captivating. As you lie here listening, imagine this star not as a problem to be solved, but as an invitation into deeper understanding. It does not ask us to discard the history of the universe. It merely asks us to re-examine the fine print, to consider that our timeline, though beautifully constructed, may still lack a chapter between the lines. There is a kind of peace in that idea, the peace that comes from remembering that knowledge is not fixed, that the universe is still capable of surprising us, that the story of everything is still being written. If you imagine yourself floating near the star, drifting gently through its pale light, you might feel a sense of awe at how long it has endured. It has watched the galaxy form and swirl and stretch. It has seen clusters merge, dust clouds collide, and worlds rise and fade. It has remained steady while entire civilizations bloomed and vanished on planets we will never see. Its existence spans a timeline so immense that human history becomes a single heartbeat against its long quiet, breathing. And yet, despite all this, it does not boast. It does not blaze with the arrogance of a star that knows it challenges the universe. It shines humbly, with a brightness just strong enough to reveal the contradiction at its core. There is something almost tender about that contradiction, something that makes the star feel less like an error and more like a clue, a hint from the cosmos that says, "You have learned much, but you have not learned everything." As your thoughts drift like shadows across the room, as the night folds softly around you, you might find comfort in this idea. The universe is not done teaching us. There are still mysteries subtle enough to slip past our instruments, patient enough to wait for our questions to catch up. The star that should not exist continues to shine with its ancient certainty, its quiet defiance, its message carried across the dark, and somewhere beneath that glow, another layer of truth waits, still hidden, ready to reveal itself when the next question is asked. And that next question lies just ahead, waiting for us to follow its light a little deeper. The deeper we listen, the more the star's quiet defiance turns into something almost fragile, as if its impossible age is not a challenge, but a confession offered with utmost gentleness. The contradiction does not shout. It stands still, like an old tree whose rings tell a story older than the forest around it. And so we return again, following the light, as if it were a thin thread stitched through the darkness, guiding us towards something we have overlooked. To know a star, you must first know the tools you use to see it. Light does not arrive at Earth unmediated. It must pass through the lenses, mirrors, and detectors we have built, each one crafted by human hands, each one carrying its own tiny imperfections. And when the anomaly is as delicate as this star's age, every instrument matters. Imagine standing in a vast hall, its ceiling hidden in shadow, its walls lined with mirrors reflecting starlight from across the cosmos. Each mirror is a way of seeing. Some are old, their surfaces worn. Others gleam with newness, sharpened by decades of refinement. The star we are studying has been reflected on all of them. And with each reflection, its story becomes a little clearer, a little harder to dismiss as an artifact of measurement. The earliest readings came from ground-based observations, where Earth's atmosphere blurs and softens the light. Even then, the star appeared older than expected. But ground-based readings can deceive, distorted by shifting air and imperfect optics. For years, astronomers waited for something better, for a vantage point above the atmosphere, a clearer line of sight. Then came a generation of telescopes that orbited above the distortions of air and weather, instruments able to catch starlight without interference. When these telescopes turned their gaze toward the ancient subgiant, the data sharpened. The distance became more certain. The brightness gained definition. The spectrum grew cleaner, its lines separating into sharper, thinner signatures. And from this clarity, the same impossible truth emerged again. It is a strange thing to find consistency in impossibility. If observations contradict each other, the mystery dissolves into noise. But when every observation agrees, when every refinement pushes the conclusion toward the same uncomfortable edge, you begin to sense that the universe is pointing at something deliberately. With this star, that is exactly what happened. As measurements improved, the uncertain haze around its age narrowed. The estimates drifted slightly downward, then upward, like a pendulum seeking equilibrium. But the equilibrium was always near the same place, so close to the age of the universe that the two became almost indistinguishable in their scale. Think of a glass filled nearly to the brim. You add a drop of water, it rises. You remove a drop, it sinks. But no matter how many drops you add or remove, the water level clings to the lip, trembling but never spilling over. That trembling edge is where this star has lived for decades of study. And so, the attention turned toward the instruments themselves. Could the star be older on paper than it was in reality because of some tiny misalignment or calibration flaw? Could the sensors that measure its brightness be subtly biased? Could the detectors that read the spectral lines be shifting the data in some hidden way? Astronomers examined these questions with the patience of people accustomed to arguing with the universe. They recalibrated detectors. They corrected for atmospheric interference. They compared measurements from different observatories to look for systematic errors. Every variation mattered, because when the difference between an ancient star and an impossible one lies in the faintest glare, you cannot afford to overlook a single fraction of light. But the star would not yield. The more precise the instruments became, the stronger its message became. Its distance remained tightly constrained. Its brightness remained high enough to match an advanced evolutionary stage. Its metallicity remained low enough to place its birth near the dawn. The instruments became better, but the contradiction remained untouched. There is something quietly profound about this moment in any scientific pursuit, the point at which you realize the error you have been hunting for might not exist. You look again at the data, hoping for a misstep in the equations or a flaw in the assumptions. But each time you trace the line of reasoning from beginning to end, it leads you back to the same place. A star whose age sits so close to the age of the universe that the difference between the two becomes a whisper. From there, attention shifted to models, those intricate mathematical portraits of how stars evolve, from birth, death. Models are not the universe itself. They are human attempts to mimic its behavior. If a model fails, that failure does not belong to the universe. It belongs to us. And so the models were examined, revised, expanded. They were tested against populations of stars with similar metallicities. They were compared with observations from star clusters whose ages we believe we understand. With each test, the same fragile boundary returned. Low metallicity stars burn slowly. They live long, but even their longevity does not explain the star's position on the evolutionary path. It should not have had time to reach its current brightness. Not unless time itself has played some trick we have not recognized. Imagine a candle placed in a quiet room. You know when you lit it. You know how long the wax should last. You watch the flame rise and fall in a predictable rhythm. Then one evening you enter the room and find the candle much shorter than it should be. The flame steady, the wax smooth, with no sign of disturbance. It has burned longer than seems possible, yet nothing in its appearance shows irregularity. You would suspect the clock, not the candle. But in this case, the clock is the universe itself. To question the models of the universe is a bold step. The age of the cosmos is not a guess. It is derived from the relic light left behind when the universe was young, a soft glow that permeates the sky even when no stars are visible. The smoothness and temperature of that glow tell a story of expansion, cooling, and unfolding structure. From those clues, we extract the time that has passed since the beginning. The idea that a star might be pressing against that boundary is not an accusation against the universe. It is a reminder that our interpretation of that relic glow may not be perfect. Perhaps the expansion rate has been slightly misread. Perhaps something subtle in the early universe is influencing the calculations. But even if that were true, the star does not sit comfortably inside the corrected timeline. It presses outward, its age brushing the boundaries even when the universe is stretched across the widest range allowed by physics. And so the focus shifts again, not because the mystery has weakened, but because it has become clear that the universe is offering a riddle that cannot be solved through a single lens. To find the answer, astronomers must consider every piece of the star's profile: its chemistry, its brightness, its distance, its motion, its oscillations, its history carved into its core. In this search, something fascinating begins to happen. The star transforms from an anomaly into a teacher. It becomes less a contradiction and more a guide, pointing toward gaps in our understanding with the patience of something that has watched ages unfold. When you lie there now, listening to the slow rhythm of your breathing, imagine yourself floating in the emptiness around the star. There is no sound, no wind, only the steady radiation from its surface, carrying with it the memory of a time when galaxies were still shapes forming out of chaos. The star does not rush. It has endured storms in the universe you can barely imagine. It has outlived structures that once shone brighter than anything you will ever see. Yet here it is, its light touching your eyes through the fragile chain of human instruments, asking only that you look closer. There is a profound intimacy in that. A star that began burning in an era when the universe was still young has carried its message across unimaginable distances, so that one day, a species on a small blue world would notice the slight mismatch between its age and the age of everything else. It is as if the star has been waiting for someone to ask the right question. The instruments we use are sharper now than they have ever been, our models more refined, our understanding broader. Yet there remains a thin veil over this particular mystery, a veil we can sense but not lift. And that veil is woven from the difference between what the star tells us and what the universe tells us. The star says, "I have lived almost as long as time itself." The universe says, "Time began not too long before that." And the space between those two statements is the place where new knowledge will one day be found. For now, that space remains an open door, inviting us to step through it, urging us to keep listening as the ancient light continues its long, steady journey toward us. And somewhere beyond that door, another layer of the star's truth waits to be revealed, patient as the dark, steady as the glow it has held for ages. And yet, as the star's ancient glow lingers, another truth rises quietly beneath it, like a second voice woven into the same whisper. The instruments that measure its light have spoken. The models that trace its evolution have offered their best explanations. But even with all of this, there is still something unresolved, something hidden not in the star's exterior, but in the subtle chemistry imprinted inside it. If the contradiction cannot be softened by refining distance, nor tamed by adjusting brightness, then the answer must be buried deeper within the elemental story of the star itself. Every star is a kind of archive, a repository of the universe's early history. The ratios of elements inside it act like sedimentary layers, preserving traces of the cosmic environment in which it was born. The star that should not exist carries a chemistry so sparse, so clean, that studying it is like reading a page torn directly from the dawn. But the deeper scientists look into its composition, the more they realize that the elements inside it do not simply describe an ancient origin. They form a pattern that is unusually pure, almost unnaturally pristine. The star's iron abundance, already known to be low, sits near the edge of what any star still surviving today can possess. Iron, forged in the depths of earlier stars, is one of the clearest indicators of cosmic age. When a star has almost no iron, it means that few, if any, supernovae had seeded its birth cloud. It means the universe itself was still in its early breath, only beginning to scatter complexity among the primordial atoms. But the iron is not the only clue. Magnesium and oxygen, the two elements most strongly tied to the earliest supernova events, are present in quantities that suggest the star formed after perhaps one or two massive explosions enriched its surroundings. That number is so small that it places the star's birth in a period when galaxies were still assembling, when the Milky Way was nothing more than a loose cloud of gravitational threads and drifting gas. And yet, even this explanation strains under the weight of the star's age. Based on its chemistry, it should be old, very old, but not impossibly old, not pressed against the universe's beginning like a fingerprint left on glass while the glass was still cooling. So researchers began to study the subtle relationships between the star's elements, looking for patterns that might reveal a more precise history. They looked at the ratio between oxygen and iron, a ratio that acts like a signature for the earliest generation of supernovae. They examined the relative amounts of carbon, nitrogen, and heavier atoms, each of which points to specific pathways of enrichment. These ratios can tell you whether a star's birth cloud was enriched by a single massive explosion, by multiple smaller ones, or by the remnants of processes that took place in stars that no longer exist. What they found was astonishing. The star's chemical fingerprint did not match any familiar pattern. It carried signs of enrichment, yes, but the ratios were too clean, too controlled. Stars born in the early universe typically show chaotic chemical signatures because the first generations of exploding stars threw their elements into space with violence and randomness. Some early stars were enriched by one supernova, some by several, and their compositions reflect that diversity. But the impossible star seemed almost curated, as if the cloud from which it formed had been touched by only a single, unusually uniform ancestral event. That kind of chemical simplicity is extraordinarily rare. It would mean that the star formed at a moment when the universe was transitioning from total elemental purity to the first faint hints of complexity. It formed from a cloud that had seen almost nothing before it, a cloud that carried just enough heavy elements to allow the star to ignite, but not enough to distort its evolution. If this interpretation is correct, then the star's age is not merely ancient, it is nearly primordial. Picture the universe as a vast, dark ocean. The first stars ignite like sparks across the water's surface, each explosion sending ripples of heavier elements outward. Most of the ocean becomes stirred, mixed, enriched by the overlapping ripples. But somewhere, at the far edge of the expanding cosmos, a single pocket of water remains untouched a little longer. There, in that pocket, the first faint mixing occurs just enough to create the conditions needed for one star to form, and that star carries the memory of that moment forever. This is the story that the elemental ratios in the impossible star seem to tell. But even as this interpretation brings us closer to understanding its birth, it carries us no nearer to resolving the contradiction of its age. If anything, the chemistry deepens the mystery. For if the star formed so early, from such pristine material, then its age should be nearly as old as the universe. That part is expected. But the star's evolutionary stage, so bright, so progressed, suggests it has aged not only near the cosmic limit, but possibly beyond it. This tension creates a kind of quiet dissonance. On one hand, the chemistry acts like a certificate of origin, stamped with the earliest epochs of cosmic time. On the other hand, the evolutionary models trace a life that seems just a little too long, a little too stretched. Chemistry says, this star is ancient. Evolution says, this star has lived almost as long as time itself. Together they whisper, but perhaps longer. It is in this whisper that the next layer of the mystery unfolds. There is a possibility, a subtle, delicate possibility, that the chemistry itself is telling a second story, parallel to the one we expect. Perhaps the absence of heavy elements affects the star's evolution in ways we have not fully captured. Heavy elements act like tiny pieces of ash in a fire. They change how heat is carried outward. They change how the outer layers expand. They influence opacity, the way light pushes through the star. If these processes differ even slightly from our models, the star could appear older than it is. But when astronomers tested this idea through simulations, a problem emerged. Adjusting the physics of low metallicity stars enough to make the impossible star comfortably younger created new inconsistencies for other well-studied stars. The models bent under the strain. They no longer fit the broader population. A correction that would save one star broke an entire category. And so the chemistry, instead of offering a solution, circled back to the same problem. The star's purity made it old. The star's brightness made it old. The star's evolutionary path made it old. Everything pointed in the same direction. It is difficult to resist the feeling that the universe is showing us something through this star, something small but essential, like a syllable missing from a sentence, or a faint stroke missing from an ancient character carved in stone. The star does not contradict the universe. It simply illuminates a part of the universe that we do not yet see clearly. As your mind settles into the quiet rhythm of breath, imagine holding the star's chemistry in your hands. Imagine each elemental ratio as a small, glowing bead. Iron sits here, nearly absent. Oxygen sits there, faint but present. Magnesium glimmers softly beside it. The arrangement is sparse, elegant, deliberate. It is the signature of a universe just beginning to breathe complexity into itself. And yet, for all its simplicity, the chemistry is not enough to explain the star's age. It tells us where the star came from, but not how it has persisted for so long. It describes its origin, but not its endurance. If anything, the elemental purity makes the endurance more astonishing. Stars born with low metallicity burn their fuel slowly. They are patient fires, consuming hydrogen with a measured pace that grants them long lifetimes. But even the most patient fire cannot outlast the wood it is given. And if this star's fire has burned longer than it should, then either the fuel is behaving in a way we do not understand, or the timeline we have built around that fire is incomplete. This realization brings a new kind of silence, one that is not unsettling, but reflective. The kind of silence that fills a room after someone says something profound, yet unfinished. We do not know the answer yet, but the question has become clearer. The chemistry of the impossible star stands not as a solution, but as a doorway. Behind that doorway lies a deeper truth about the early universe, about the first generation of stars, and perhaps even about the way time itself unfolded in those distant epochs. The doorway is open now, and the star waits on the other side, its ancient elements glowing softly, inviting us to step through. Yet even as the chemistry opens its quiet doorway, another presence waits behind it, something more elusive than elemental ratios or spectral lines. It is not found in the star's surface, nor in the brightness that reaches us, nor in the metallicity that marks its ancient birth. Instead, it lies in the way this star moves through the galaxy, in the path it has carved through space for almost the entire lifetime of the cosmos. If we want to understand why its age strains against the limits of time, we must follow that path. The motion of a star is a kind of handwriting, an old script traced out not by ink but by momentum. Each orbit around the center of the Milky Way is a slow, sweeping stroke, shaped by the gravity of the galaxy and the memory of the star's birthplace. A young star moves in a gentle curve, nestled safely within the rotating disk, following the rhythm of billions of others. An old star moves differently, often cutting high arcs above and below the galactic plane, signs of a time when the Milky Way was still young and turbulent. The impossible star does not follow the smooth, circular orbit of the galactic disk. Instead, it travels on a long, stretched path that rises far above the Milky Way's thin plane before sinking back down again, as if tracing the breath of a giant creature sleeping in the dark. Such orbits belong to the oldest populations of stars, remnants from the galaxy's earliest days, survivors of mergers, collisions, and gravitational reshaping. If you could watch its movement sped up a millionfold, you would see it glide outward, arc upward, then sweep back toward the center in a long, graceful curve. It does not hurry. It has repeated this journey countless times, crossing regions of the galaxy that have changed dramatically since it was born. Dust clouds that were once dense have dissipated. Star clusters that once shone brightly have dispersed into isolated points. Entire generations of stars have formed and died in the time it takes this lone star to complete only a handful of orbits. Its motion is a testament to its age, but motion alone is not enough to solve the mystery. What makes the orbit truly fascinating is not just that it is old, but that it matches the story told by the star's chemistry. Both point to an origin outside the familiar, orderly disk of the Milky Way. Both suggest a birth in a chaotic early environment, possibly even in a smaller, ancient galaxy, swallowed by our own long before human eyes ever opened to the sky. Imagine, for a moment, a tiny dwarf galaxy drifting through the early universe. It is quiet, sparse, filled with gas, barely enriched by the first supernovae. In that quiet place, the impossible star may have formed. And as the Milky Way grew, pulling smaller galaxies into its gravity, perhaps this tiny galaxy was absorbed, its contents scattered like seeds across the young galactic halo. Most of its stars would blend invisibly into the growing population. But one star, this star, would continue on its long, solitary orbit, carrying with it the memory of that forgotten home. If this scenario is true, then the star's chemistry is not only a clue to its age, but also a map of its birthplace. And its orbit becomes a record of its journey, preserved through billions of years. But even this elegant picture does not fully solve the contradiction of its age, because the orbit, like the chemistry, confirms what we already know. The star is ancient, very ancient. but not ancient enough to explain why it sits so close to the universe's own boundary line. Nothing in its motion suggests a trick of physics that could stretch its age further than expected. Nothing in its path reveals a loophole that would allow it to evolve more quickly or more slowly than predicted. Instead, its orbit deepens the mystery by adding a new layer of certainty. Everything about the star's motion agrees with everything about its composition, and everything about its composition agrees with everything about its brightness and temperature. They all converge toward the same conclusion, a conclusion that stands on the very edge of cosmic time. The more the data agree, the harder it data becomes to blame error. That agreement forms a kind of quiet harmony, a chorus of evidence singing the same improbable note. It is not an easy note to hear. It sounds like a subtle tension, a delicate mismatch, something you might miss if you were not listening carefully. But once you hear it, it echoes everywhere. Astronomers have tried to shift the note by examining every factor that might influence the star's orbit. They studied its velocity with exquisite precision, measuring how fast it moves toward or away from us, how fast it sweeps across the sky. They calculated the gravitational interactions it experiences as it passes through the galaxy. They compared its path with simulated orbits of stars from ancient galactic mergers. Each test brought the same answer. The star behaves exactly as an extremely old star should. Its orbit is not an anomaly. Its motion is not a mistake. It is consistent, stable, and utterly ordinary for a relic of the early Milky Way. That ordinariness is what makes the situation extraordinary. The more typical the star appears in every other aspect, the more extraordinary its age becomes. If a star is unusual in many ways, an extra unusual age might be dismissed as part of a broader strangeness. But when everything else about the star fits so cleanly into what we understand, the age stands out like a single discordant note in an otherwise perfect chord. As you lie here listening, imagine tracing the star's orbit through the vast halo of the galaxy, following its path like a thread through a tapestry woven over cosmic time. You float alongside it, watching as it sweeps over the galactic disk, rising into regions where only ancient stars roam. You feel the gentle pull of gravity shaping its arc, and you sense how many cycles it has completed, how many times it has watched the Milky Way spin beneath it. There is something almost meditative about imagining a motion that's slow, that's steady, that enduring. The star has been following the same rhythm since long before your world formed, long before the sun ignited, long before the spiral arms of the Milky Way settled into their current shape. Its orbit is not simply a path through space, it is a timeline, and the timeline whispers the same thing as the chemistry. The star is as ancient as it appears. As you drift deeper into this thought, a new possibility emerges from the darkness, one that astronomers have quietly considered, even though it brings no easy answers. Perhaps the contradiction lies not in the star, but in our understanding of time. When we measure the age of the universe, we rely on models that interpret the expansion of space, the cooling of the cosmic background, and the growth of structure over billions of years. These models fit beautifully with most observations. But what if there is a subtle piece missing? What if a small correction, hidden somewhere in the early behavior of space, would shift the cosmic timeline, just enough to bring the star's age comfortably inside it? No one wants to reach for this explanation too quickly. The age of the universe is one of the most well-supported numbers in modern science. But when a single star presses so persistently against that boundary, refusing to step back, refusing to be explained away, it becomes difficult not to wonder. You do not need to leap to conclusions. You do not need to discard the models or rewrite cosmic history. You only need to acknowledge that there is something here, a tension, a puzzle, a gap that invites exploration. The orbit of the star does not reveal the solution, but it reveals something just as important, the consistency of the contradiction. Every measurement aligns, every clue agrees, every piece of evidence, from chemistry to brightness to motion, points toward the same strange truth. The star is old, and the universe may be just a little bit older, or perhaps time itself holds a softness in its early moments that we have not yet learned to read. As the galaxy turns slowly beneath the star's ancient path, the contradiction deepens, settling into the space between what we know and what we have yet to discover. And somewhere in that space, the next piece of the puzzle waits, still hidden, but not for long. And still, even after tracing its path across the galaxy and weighing the purity of its elemental fingerprint, the mystery deepens when we look inward into the very heart of the star itself. Because the truth of a star's age is not written on its surface or in its orbit, but in the slow, measured burning of the fire within it, a fire that has been unfolding since the earliest chapters of time. If you could drift inside that ancient glow, letting the outer layers fall away like veils of soft light, you would find a core that burns with a calmness only the oldest stars possess. The pressure there is immense, yet it does not rage or roar. It works with a quiet discipline, fusing hydrogen into helium, one breath at a time, as if the star has spent its entire life practicing patience. Inside this impossible star, the fusion processes unfold more slowly than in younger, heavier stars. Low metallicity acts like a subtle restraint, reducing the scattering of photons, allowing energy to move outward with fewer obstacles. This slower energy flow cools the outer layers slightly and stretches the star's fuel supply in a way that should grant it a long, steady life, though not one exceeding the cosmic limits. But as astronomers began to model this inner fire with increasing precision, something peculiar emerged. For a star with such low metallicity, the expected evolution would place it lower on the subgiant branch than where we find it. It should be dimmer, slightly bluer, its envelope less expanded. But instead, the star shines with the brightness of a subgiant that has nearly exhausted its hydrogen core, standing at a point in its evolution that seems stretched, elongated, as if the journey from youth to its current state took more time than the universe has allowed. It is here, in this quiet contradiction, that the mystery sharpens. Every star ages by transforming fuel into new elements. As hydrogen diminishes in the core, helium ash gathers and changes how energy moves through the interior. The core contracts, the outer layers swell, the brightness increases. These transitions happen slowly, but they happen predictably. Stellar evolution is not random. It is one of the most reliable clocks in astrophysics. And yet, when that clock is pointed at this ancient subgiant, the hands do not align with the ticking of cosmic history. The core shows signs of having burned for longer than seems possible. The expanding envelope suggests a lifetime stretched almost to the limit, and perhaps a little beyond it. To make sense of this, astronomers studied the star's oscillations, faint pulses on its surface caused by waves traveling through the interior. These pulsations act like seismic clues, allowing scientists to map the density and structure within. The pattern of the oscillations confirmed what the brightness already implied. The star's core is older than its metallicity alone can account for. It has been burning for an extraordinarily long time, long enough to press against the cosmic boundaries of possibility. Imagine listening to a drum carved from ancient wood. When you strike its surface, the sound it produces carries the age of the tree that bore it, the density of the rings, the stories written layer by layer. The star's oscillations are like that sound. They carry the history of the interior, and that history does not lie. But here is the strange part. The core appears older than the envelope. The interior tells a story of a star that has lived nearly the full span allowed by the universe. But the outer layers have not aged into the shape expected for such an ancient fire. They carry patterns that belong to a star, slightly younger, slightly less evolved. It is as if the heart of the star is racing ahead of time, while the surface lingers behind. This disjointed aging is not something we see in ordinary stars. Normally, the core and envelope evolve together, like two dancers moving in synchronized steps across a stage. But in this star, the rhythm is off by a margin so small it seems impossible, and yet so precise it cannot be ignored. Why would the core age more quickly than the outer layers? Why would the envelope resist the degree of expansion expected of a star this old? These questions pull us deeper into the nuclear physics of the star, into the subtleties of hydrogen fusion and energy transport. One theory suggests that helium diffusion inside the star may behave differently in extremely metal-poor conditions. If helium sinks more quickly than expected, the core could evolve faster, leaving the outer layers behind in a state that masks the star's true age. But when simulated, this effect is too small to account for the full discrepancy. Another idea proposes that the star may have lost a tiny fraction of its mass earlier in life. Mass loss can change a star's evolution in delicate ways, altering brightness and temperature. But again, the amount of mass needed to resolve the contradiction would disrupt other parts of the star's behavior, creating inconsistencies that observations do not support. Still, another possibility considers the star's rotation. A slow rotation can change how elements mix inside a star, separating layers with subtle effects on evolution. But the impossible star rotates so slowly that rotation cannot be a significant factor. One by one, the traditional explanations fall away. They help a little, but not enough. They bend the models, but do not bring them into harmony with the star we see. And so the focus deepens inward, into the quiet nuclear processes themselves. Hydrogen fuses into helium through two main chains, each sensitive to temperature, density, and composition. In extremely metal-poor stars, the first chain, the one that dominates in stars like this, proceeds at a rate that stretches the star's fuel supply. This should make the star live longer, yes, but not this long. Not long enough to brush against the age of the universe like a hand touching a window that should not be opened. As you sink deeper into this thought, imagine the core of the star as a glowing sphere resting beneath layers of silence. Each fusion reaction is a quiet breath, releasing light that has traveled across almost the entire history of existence to reach your eyes. And that breath has been steady, patient, unbroken for so long that time itself begins to feel different in its presence. What if time, in the earliest epochs, unfolded with a slightly different rhythm than the one we measure today? Not a dramatic shift, but a gentle one, a slight softness in the unfolding of the first cosmic ages, an elasticity in the timeline that allowed the star's early evolution to stretch just a little longer than expected. This idea is delicate. It does not overthrow the age of the universe. It does not rewrite cosmic history. It only suggests that the earliest moments may have held subtleties that we have not fully captured in our equations. Subtleties that could have nudged the clock of this star just enough to bring it beyond the edges of what we currently consider possible. If you listen to the universe long enough, you begin to sense this softness, this feeling that our measurements, though precise, may still be incomplete in the earliest frames of cosmic time. The impossible star seems to hold part of that missing frame inside it, carried in the rhythm of its core, preserved in the slow glow that has traveled across epochs. As you breathe gently now, imagine floating inside that inner fire, watching hydrogen transform into helium in a slow procession of reactions, each one a step forward in a dance older than galaxies. You feel the weight of ages pressing outward, the calm determination of a star that has refused to extinguish itself before its message is understood. And that message, though still incomplete, becomes clearer with each layer we explore. The core is old, older than expected. The envelope is old, yet slightly younger than the core would demand. The fusion processes are steady but stretched. The evolutionary path is familiar but extended. The star has lived a life that pushes against the boundaries of cosmic time, and the physics inside it reflects that pressure with quiet honesty. As you let your thoughts drift, something profound becomes clear. The mystery is no longer about whether the star is old. It is about how it has managed to remain so perfectly balanced on the edge of possibility. It is as if the star has been tuning itself to the rhythm of the universe since the very beginning, holding its fire with such discipline that it has survived the full span of cosmic history, waiting for us to notice. And now that we have noticed, its inner fire offers a new truth, one that leads deeper still into the next question waiting in the heart of the mystery. And yet, even as we peer into the quiet fire of the star's core, another truth waits just beyond reach, lingering in the space where physics meets uncertainty. Because no matter how deeply we examine its inner rhythms, no matter how carefully we map the glow of its ancient fusion, the contradiction remains untouched. The star is old, uncomfortably old, and somewhere in that uncomfortable space, the universe seems to hold a breath we have not yet learned to hear. If the core is truly as ancient as the oscillations suggest, then there must be something in the earliest chapters of cosmic time that shaped its evolution in ways we have not fully captured. To understand this, astronomers turn their attention not only inward, but outward toward the way time itself behaved in the earliest breaths of the universe. Time, in the cosmic sense, is not a simple, steady river. It is more like a fabric, shaped by expansion, density, and energy. In the early universe, when matter was tightly compressed and temperatures unimaginably high, time did not flow with the same gentle consistency it holds now. It thickened, stretched, curved around forces far stronger than anything we experience in the quiet space of the present. Picture a drumhead struck while still warm from being stretched. The sound it produces carries a slight wavering, a softness, because the tension has not yet settled. The early universe may have held a similar softness, a momentary looseness in the unfolding of time itself. If that softness lasted even a little longer than our equations assume, it could have allowed the first generation of stars to begin burning sooner than expected, giving relics like this one a head start before the cosmic clock settled into its regular pulse. But even this idea remains speculative, a gentle possibility rather than a firm conclusion. So astronomers looked instead at the star's environment in those earliest epochs. They considered the density of the gas from which it formed, the temperature of the early interstellar medium, the faint turbulence left behind by the first supernovae. If the star formed from a cloud more compressed than assumed, its early evolution could have been accelerated. If it formed from a cloud more diffuse, its early evolution could have been delayed. Each scenario shifts the star's lifetime slightly, like adjusting the tension on a stringed instrument. But none of these shifts were enough to close the gap. The star continued to sit on the boundary, whispering the same improbable message. In moments like this, when science meets a contradiction that refuses to bend, something subtle happens. We begin to search not only for answers, but for the hidden assumptions we carry without realizing it. Assumptions about how the universe began, how quickly it cooled, how matter settled into clouds dense enough to form stars. Assumptions about the exact moment when the first stable atoms formed, about how energy flowed through the primordial plasma, about how long it truly took for darkness to dissolve into the first light. This star pushes on those assumptions with the gentlest possible pressure, like a fingertip testing a door that may or may not be locked. It does not demand that we abandon the cosmic timeline. It simply asks us to look again at the earliest frames, to see whether something small has been overlooked. As you lie here listening, imagine drifting backward through the ages, through the long arc of the star's orbit, through the layers of its fusion, through the sparse chemistry of its birth cloud, through the gravity that pulled its atoms together. Keep drifting until you reach a time before the star existed at all, a time when the universe was still bright with the afterglow of its beginning. In that moment, space was dense enough to press against itself. Light had not yet learned how to travel freely. Atoms were not trapped in stars, but wandering separately, bumping through a fog of charged particles. If the star's story began here, then perhaps even the faintest difference in density or temperature could ripple forward into its present age. These are not casual thoughts. They require imagining the universe not as a fixed structure, but as a living, unfolding process, one in which small uncertainties can echo across billions of years. The impossible star may be carrying one such echo, encoded in the shape of its evolution. Some astronomers have wondered whether the earliest stars formed in a staggered way, with pockets of gas beginning to collapse before the main epoch of star formation officially began. If the impossible star came from such a pocket island of early cooling in the ocean of primordial heat, it could have ignited sooner than predicted. Not by much, only by the smallest fraction of the cosmic timeline. But that fraction may be enough to explain the star's uncanny age. Others suggest that early gravitational turbulence could have accelerated certain regions of space, pulling matter together faster, allowing stars to form ahead of schedule. In such a scenario, the impossible star might be the survivor of a cluster that formed in a moment of early cosmic hurry, its siblings long gone, its memory carried alone in the halo of the Milky Way. But even these explanations stretch our understanding in ways that feel fragile, as if the truth is still hiding behind another layer of the mystery. Because if the star had formed significantly earlier, we would expect its chemical fingerprint to carry an even simpler pattern, perhaps nearly pure hydrogen and helium. Yet the star contains faint traces of heavier elements, suggesting it was born not at the very dawn, but just after. This makes its age even harder to reconcile. It is like encountering a tree whose rings say it sprouted soon after the forest formed, yet its height suggests it began growing before the forest even existed. Everything aligns, but only barely. Every measurement agrees, but only just. And in this delicate almost agreement, the mystery becomes even more haunting. As your breathing softens, imagine hovering near the star again, feeling the heat rising quietly from its surface, watching the layers shift with the slow patience of something that has endured almost the entire lifetime of the cosmos. It does not rush to reveal its secrets. It simply continues to burn, as if waiting for someone to notice that its endurance carries a deeper meaning. Perhaps the star is teaching us something about limits, about how the universe holds its boundaries, not with rigid certainty, but with subtle, flexible grace. The star does not break the boundary of cosmic time. It rests on it, as lightly as a feather settling on a ledge. It sits so close to the edge that the edge itself begins to feel less absolute. The more we listen, the more that edge feels like an invitation rather than a rule. An invitation to imagine the early universe more fully. An invitation to reconsider the quiet physics of ancient stars. An invitation to let the mystery breathe, instead of forcing it into familiar shapes. As the night deepens around you, the star's message becomes clearer, not in content, but in feeling. It is not trying to tell us that the universe is wrong. It is trying to tell us that the universe is not finished, that there are still chapters we have not read, that the early moments of time may hold subtleties we have not yet learned how to sense. And so, the star waits, and we listen. And between the two, a thin thread of curiosity stretches across the dark, guiding us toward the next unanswered question. Because the next layer of this mystery lies not in the chemistry, not in the orbit, not in the core, but in the place where all these clues converge, where the contradiction sharpens into a turning point the universe has been holding for a very long time. And yet, as we drift toward the place where all these threads gather, another truth rises from the quiet. The truth that our models, the delicate frameworks we use to understand stars and time, may be approaching the edges of their own ability to explain. The impossible star is not simply resisting explanation. It is pressing gently against the boundaries of what our equations can currently hold, asking us to consider that something within them may be incomplete, not broken, but unfinished in the way a half-written sentence waits for the next word. This is the moment when the universe becomes a teacher again. For all our elegance in describing stars, our models are still approximations, tools shaped by observation and logic, but never identical to the reality they represent. A model is a ship carved from the wood we have gathered, but the sea it sails on is deeper than anything we can see from shore. When a star pushes against the model, the pressure is not against truth, it is against our version of truth. And this ancient subgiant presses everywhere at once. Its brightness pushes on how we calculate stellar evolution. Its chemistry pushes on how we reconstruct the earliest supernovae. Its core structure pushes on how we model fusion in low metallicity environments. Its orbit pushes on how we trace the kinematics of ancient stars. And together, all these pressures converge on the greater boundary, the age of the universe itself. When astronomers realized how consistently the data pointed to this contradiction, they began to examine the foundations of those models with a kind of reverent caution, not because they doubted everything they knew, but because something in the star's light suggested that a small, easily overlooked assumption might be hiding in the early equations. The first place they looked was the expansion rate of the universe, a value woven into nearly every model of stellar age. If the expansion has been interpreted with even the slightest bias, the timeline could shift in subtle ways. Some measurements rely on distant galaxies, whose light stretches as space expands. Others depend on the faint glow of the cosmic background, a remnant from the first moments after the beginning. These two methods sometimes disagree by a small but persistent margin, a tension that has grown more pronounced in recent years. The impossible star does not solve that tension, but it sits in the middle of it, like a patient witness to a dispute older than our instruments. Its age seems to lean toward the idea that the universe might be slightly older than our most widely accepted estimates. Not dramatically older, not enough to rewrite the entire story of cosmic evolution, but enough to soften the contradiction between measured star ages and measured cosmic time. And yet, even if the universe were granted a little more age, the star remains eerily close to the limit. It does not fall comfortably within a widened boundary. It hovers on it, as though this limit were precisely where it has always been meant to rest. This is what makes the mystery so compelling. If the star simply exceeded the age of the universe, the answer would likely be simple: an observational mistake or a model that required correction. But the star does not exceed the universe. It touches the edge with perfect, improbable precision. It is not breaking the rules. It is showing us where the rules become thin. To understand this tightness, astronomers turned next to the physics of opacity, the measure of how easily light moves through a star's interior. If light can escape more freely, the star remains cooler and dimmer. If it struggles to escape, the star brightens and evolves more quickly. Opacity depends delicately on the presence of heavy elements. So in a star with very low metallicity, tiny errors in calculating opacity can ripple into large differences in age. But when opacity models were refined, the contradiction only narrowed further. Each improvement brought the star closer to the very boundary it already hugged, as if the universe were adjusting the frame around it to keep the contradiction intact. Other refinements followed: adjustments to helium diffusion, corrections to convective mixing, revisions to nuclear reaction rates. Each change softened a corner or smoothed an edge, but nothing resolved the center of the contradiction. Nothing reshaped the star's age enough to tame its defiant proximity to cosmic limits. In the quiet of night, lying still, you might imagine the models laid out before you like fragile diagrams drawn in dust. Every stroke represents a law, a constant, a principle guiding the evolution of stars. Then imagine the star itself, a single point of ancient light settling gently onto the diagram. and watch as the lines tremble, not collapsing, but quivering with the strain of accommodating something that fits too tightly. There is a humility in moments like this, when the boundary between knowledge and uncertainty becomes visible. The star is not a mistake. The models are not wrong, but the space between them is where discovery waits. Perhaps the earliest universe expanded in a slightly more complex rhythm than we assume. Perhaps the first clouds of gas cooled unevenly, allowing some stars to ignite sooner. Perhaps the nuclear processes in extremely metal-poor stars include subtleties we have yet to uncover. Or perhaps the cosmic timeline itself holds a softness in its infancy, a small elasticity that the impossible star now reveals. Whatever the answer is, it awaits in the next questions raised by this single ancient flame. And so, as your thoughts settle into the stillness around you, imagine the models of stellar evolution not as perfect maps, but as evolving sketches, guided by stars like this one. With each contradiction, the sketches grow clearer. With each mystery, they gather depth. The impossible star is not an exception, it is a teacher, showing us where our understanding must deepen. The models tremble, but they do not break. The star glows, but it does not yield. And between the two, a path opens toward the next layer of truth, carrying us deeper into the heart of the universe's oldest questions. And yet, as the models tremble beneath the star's ancient weight, something begins to shift in the space between certainty and doubt. It is not a collapse or a failure. It is more like a quiet realization, the kind that arrives after a long night of searching, when the sky begins to brighten and you finally see that the path you have been walking is broader than you first believed. Because if every refinement brings the star closer to the very edge of cosmic possibility, if every correction tightens rather than loosens the contradiction, then perhaps the contradiction is not meant to dissolve. Perhaps it is meant to point toward a deeper truth waiting just beyond the horizon of what we can currently describe. This is the moment when the universe whispers a turning thought. For generations, we have calculated the age of the cosmos through the rhythm of its expansion, through the faint glow left behind from its earliest light, through the clustering of galaxies, through the distribution of matter across distances so vast that even imagination must stretch to follow. These methods have converged with remarkable consistency, producing an age we trust with near certainty. But what if that certainty is only part of the story? What if the expansion carries a subtle echo from the earliest moments, an echo too faint to alter the sweeping picture of cosmic evolution, yet strong enough to shape the earliest stages of star formation? It would not take a dramatic shift, not a rewriting of the universe, but a small, quiet adjustment, just enough to soften the boundary that this ancient star presses against. And as scientists began to consider this possibility, the contradiction suddenly felt less like an error and more like an invitation to revisit the early universe with a gentler eye, to examine its first breaths not as fixed certainties, but as evolving possibilities. Imagine the universe in its early youth, expanding with a speed that carried both precision and chaos. At that time, energy and matter moved through each other like currents beneath a storm-dark sea. Tiny differences in density, pressure, or temperature could have given rise to pockets of accelerated formation, places where the first stars ignited slightly sooner than our models allow. If the impossible star formed in one of those pockets in one of those early breaths of cosmic variation, then its age might be telling us not that we are wrong, but that the cosmos carries more texture than we once believed. This realization is subtle but profound. It marks the first turning point in the entire mystery. For a long time, the impossible star seemed to stand alone, a single outlier on the edge of the graph. But now, as observations improve across the sky, we find other stars that lean quietly towards similar boundaries, not as dramatically, not as defiantly, but enough to suggest a pattern on the horizon. They do not push the limit the way this ancient subgiant does, but they drift close enough to whisper the same gentle message. The earliest universe may be more complex than we have drawn. You can feel that shift in the air of the scientific world, the moment when a long-standing puzzle begins to shape itself into a new understanding. This is not a declaration, it is a breath, a soft repositioning of thought. The models hold, but the edges of those models begin to glow. If you imagine these early stars as lanterns placed along a distant path, then the impossible star is the lantern turned slightly brighter, illuminating a wider portion of the road. You see shapes you had not noticed before, hints of structure at the edges of memory. And though the path remains dark, it no longer feels empty. As you lie here now, letting your breathing slow, imagine that path stretching away from you. At the far end of it, nearly touching the dawn, stands the impossible star, its brightness steady, illuminating the limit of the timeline. It is not pointing backward toward what we thought we knew. It is pointing forward toward what we have not yet learned. This is the mini-climax. The mystery has been approaching. Not a burst of revelation, but a shift in perspective so gentle you might miss it if you were not listening closely. The question is no longer, how can this star exist? The question becomes, what does the star reveal about the universe around it? When seen this way, the contradiction transforms. It becomes less a conflict and more a clue, less a defiance of cosmic age and more a signpost on the map of early time. Perhaps the universe is slightly older than our instruments measure. Perhaps the earliest star-forming clouds ignited sooner than our equations predict. Perhaps something in the first breaths of cosmic expansion carries a softness that has not fully settled into our understanding. None of these ideas undermine the universe. They enrich it, adding texture, depth, and nuance to a story still unfolding. As your mind drifts into the softness of this thought, imagine the star again, calm, ancient, steady. It does not ask us to abandon the timeline we trust. It asks us to refine it, to look more closely, to allow the earliest chapters of existence to be not rigid, but alive, shaped by forces we have only begun to glimpse. The star waits on the edge of possibility, and in its waiting, it teaches us the simplest truth of all. Understanding is not a destination, it is a continuous horizon. And beyond that horizon, the next layer of the star's mystery is already rising, ready to carry us deeper into the shape of cosmic time. A softer truth begins to rise beneath the glow of the ancient star, as if the universe itself were shifting its weight, preparing to reveal something it has carried in silence for far too long. The mystery has stretched across every layer we have examined, its chemistry, its orbit, its interior, its evolution, and still it waits, steady and unbroken, asking us to recognize what lies just beyond the surface. There comes a moment in every long search where the question no longer feels like a barrier, but a doorway. That moment has arrived. For so long, we have tried to reconcile the impossible star with the age of the universe by adjusting the instruments, refining the models, polishing the equations. But the more we refine, the more the contradiction intensifies, not because the star refuses to fit, but because everything we adjust pushes our understanding a little closer to a boundary we did not realize was there. What if we have been looking at the contradiction from the wrong direction? What if the star is not stretching beyond the universe, but instead revealing a place where our measurement of the universe has remained incomplete? This is the turning point the mystery has been guiding us toward. To reach it, we must return once more to the star's inner fire. The fusion inside it has burned with the gentlest persistence, transforming hydrogen into helium across nearly the entire cosmic story. Its oscillations, its brightness, its density, all of them speak with the same quiet clarity. But beneath that clarity is something else, a rhythm that does not quite match the models we use to understand how such stars age. Not a contradiction, a subtle drift, a shift barely visible, yet profoundly important. If the early universe expanded with even a whisper more complexity than we currently assume, then the timelines we use to measure its age would settle slightly differently. The beginning would not move dramatically. It would not leap forward or collapse backward. It would simply widen by the smallest margin, like a curtain being drawn open just a little more to let the first light of morning through. In that widened space, the impossible star suddenly becomes possible. It does not need the universe to be vastly older. It does not need special physics reserved only for itself. It only needs a fraction of time in the earliest moments to be shaped differently, a softness that has long been hidden beneath the mathematics of expansion. This is the moment the contradiction becomes a compass. Everything we have observed, everything we have measured, everything we have struggled to reconcile, converges on a simple truth. The star is not defying the universe. It is illuminating a gap in our understanding of the universe's first breath. Imagine the beginning of time, not as a single, sharp transition, but as a period that settled into steadiness gradually, like a pot of water cooling after a rolling boil. The earliest instance could have carried slight variations in expansion speed, density, or energy distribution. These variations would not rewrite cosmic evolution. They would not alter the way galaxies formed or stars gathered into spirals, but they could shift the beginning just enough to give the impossible star the room it needs. Such a shift would be small, so small that nothing else demands it. But the star demands it simply by existing. As you lie here listening, imagine the early universe stretching into place. Imagine the first atoms forming with a faint tremble, the first clouds gathering with an uneven rhythm, the first stars igniting not in perfect synchrony, but with tiny variations across the deep dark. Somewhere among those variations, a single cloud may have collapsed just a moment sooner, igniting the impossible star at a time that sits on the edge of what we believe is possible. This perspective does not diminish the universe. It enriches it, giving its earliest chapters more texture, more nuance, more depth. The turning point, then, is not about the star. It is about us. It is about recognizing that even our most trusted measurements, those that describe the universe's age, its growth, its history, are not carved in stone. They are precise, but precision does not equal perfection. They are consistent, but consistency does not guarantee completeness. The impossible star shows us that truth with extraordinary grace. Its age is not an error. Its evolution is not a mistake. Its brightness is not an illusion. It has lived a life shaped by conditions so old, so delicate, that our current understanding is only beginning to touch them. As this realization settles into place, the contradiction that once felt like a wall begins to feel like an opening. A quiet shift happens inside you, the same shift happening across the world of astronomy, the sense that the star is gently guiding us to widen our view of the origin of time itself. It is not the universe that must be rewritten. It is our interpretation of its earliest heartbeat. And in that heartbeat lies the next revelation waiting to unfold, one that will carry us deeper into the structure of ancient stars, deeper into the nature of cosmic beginnings, deeper into the fabric of time itself. The impossible star has brought us to the threshold. Now it waits for us to step through. Something quiet eases into view as we cross the threshold of this turning point, like a faint shimmer appearing at the edge of vision when your eyes finally adjust to a darker room. It is not revelation and not warning. It is the calm recognition that if the star is guiding us toward deeper understanding, then the next step must involve returning to the models one more time, not to force them to fit, but to see which parts of them still whisper truths we have not yet heard. For the longest time, the contradiction has rested on the sharp line between the star's age and the age of the universe. But beneath that sharpness lies a softer landscape of details, fine adjustments that astronomers have explored with patience, hoping that within those subtleties a clearer harmony might emerge. These adjustments begin with the way energy moves through the star. In stars with such low metallicity, Photons travel differently, slipping through sparse layers with fewer obstacles. This changes the temperature gradient, the structure of the core, and the speed at which fuel is consumed. In theory, small refinements to these parameters might nudge the star's evolutionary track into a gentler curve, bringing its age a bit closer to comfort. But each refinement has the same outcome. The models bend, the numbers shift, and still, the star's age remains pressed against the cosmic limit, unyielding. It is not that the refinements fail. They simply do not change the conclusion in a meaningful way. One of the first attempts was to adjust helium diffusion inside the star. Helium atoms slowly sink over long periods, gathering in the core in ways that subtly alter the star's structure. If helium diffuses more efficiently than expected, the core evolves faster, and the outer layers can appear deceptively young. But when this process is simulated with increasingly realistic physics, the effect is too gentle to bridge the full gap. The star remains older than it should be. Another adjustment focuses on the mixing of elements carried by convection. In stars like this ancient subgiant, convection is not as dominant as in younger, more metal-rich stars, but it still shapes the outer regions. By altering the efficiency of mixing, the models can shift the star's brightness slightly, changing its inferred age. But again, the corrections are too small, ripples on the surface rather than waves that reshape the result. The contradiction holds steady. Even the nuclear reaction rates themselves have been revisited. The speed at which hydrogen transforms into helium depends on a set of reactions that have been studied in laboratories and compared across stellar populations. But the universe is not a laboratory. In the earliest stars, the conditions are harsher, more extreme. If the reaction rates were even slightly different in those ancient environments, the star's lifetime might stretch in subtle ways. And yet, despite carefully updated rates, the lifetime stretches nowhere near enough. The models soften at the edges, but the core of the contradiction remains untouched, almost serene in its persistence. As you lie here listening, imagine the models as delicate clockwork, gears meshing in, patterns that have been honed for generations. Each refinement is a craftsman adjusting a single tooth on a single wheel, hoping that just the right correction will bring the mechanism into perfect alignment. But when the craftsman steps back, the hands still point to the same impossible time. This realization sparks a shift, not in the models, but in the people who build them. There is a moment when you accept that the tools you are using are not flawed, but simply incomplete. They describe the world beautifully up to a point. Beyond that point, they fall quiet. The impossible star stands at that quiet edge. Its age, so close to the age of the universe itself, creates a tension that none of these fine adjustments can dissolve. The more precisely we measure helium diffusion, the more carefully we describe opacity, the more accurately we model the nuclear chains inside the core, the less room there is left for the star to hide inside uncertainty. Uncertainty shrinks. The contradiction remains. This is not a failure. It is a revelation of its own. Because when subtle corrections fail, they tell us that the answer lies not in the small adjustments, but in the larger frame that holds them. As your thoughts grow softer, picture the star as a lantern, illuminating the boundary of what our equations can currently reach. Each refinement brightens the lantern a little, making the boundary clearer rather than moving it. With every improvement, the models whisper the same message. The star is ancient. The universe is ancient. And the space between these two truths is narrower than we imagined. It is in this narrowing that the next layer of the mystery forms. Scientists begin to wonder whether the earliest universe allowed stars to evolve differently in ways that cannot be captured by altering a single variable. Perhaps the interactions between radiation and matter were influenced by conditions no longer present. Perhaps the earliest pockets of star formation contained complexities invisible to later generations. Perhaps the first moments after the beginning were shaped by a rhythm of expansion that left subtle fingerprints inside stars like this one. These ideas do not discard the models, they expand them. They hint that the earliest cosmic time may hold features not yet woven into the equations. And the impossible star becomes a messenger, carrying those features across billions of years of space. Imagine drifting inside the star's outer layers now, watching the patterns of convection and radiation blend together like currents under a surface of warm water. Beneath you lies the core, pulsing with the slow certainty of hydrogen fusion. Around you, the envelope glows with a brightness that should not quite exist. The star breathes with the calm of something that has lived longer than the story used to describe it. And all the while, the fine details, diffusion, mixing, opacity, reaction rates move like quiet threads through the star's life, too gentle to change the ending, too honest to conceal the truth. They tell us that we have reached the limit of what refinement alone can reveal. They tell us that the contradiction is not noise, it is signal, a guide, a threshold, the edge of a deeper understanding waiting to unfold. And beyond that edge, the mystery grows more compelling. The star has led us through composition, through motion, through inner fire, through the shape of early time, and through the limits of our models. Now it draws us towards something even more intimate, the story of the universe's infancy itself, where its true answer may be found. There comes a quiet moment in every long inquiry when the question no longer feels external, no longer stands apart from the one who asks it. Instead, it settles inward, resting close to the observer like a companion who has been walking beside you the entire time. The impossible star has reached that moment. After guiding us through its chemistry, its orbit, its interior, and the limitations of our models, it now invites us to consider something even more delicate, the way our own understanding shapes what we believe to be possible. As we follow the star deeper into its mystery, a subtle shift happens, not in the universe, but in us. For so long, we have held to the idea that the age of the universe is a firmly drawn line, a clean boundary separating what came before from what came after. But now, as the star's quiet glow continues to press against that line, we begin to realize that boundaries are rarely as rigid as they appear. They are concepts we create to bring order to something far larger than ourselves. The star's defiance of those boundaries does not break them. It exposes the softness beneath them. When astronomers first recognized that its age brushed the cosmic limit, they felt something close to discomfort, an instinctive pull to protect the familiar shape of the universe. But with time, something gentler replaced that discomfort: curiosity, a sense that the contradiction was not an error, but a mirror, reflecting the assumptions woven into our understanding. If you lie still for a moment and imagine the star as more than light, imagine it as a presence, you might sense the same shift. Its glow is ancient, but its message is new. It asks us to look inward, quietly, at the frameworks we have used to interpret the universe. One of those frameworks is the belief that time flows uniformly across all eras, that the same processes shaping stars today shape the earliest stars in the same way. But nothing in the universe is truly uniform. Even time is influenced by the density of space, the distribution of matter, the flow of energy. In the earliest epochs, everything was different, denser, hotter, more turbulent. If our understanding of that era is incomplete, then the star's age is not contradicting the universe. It is showing us a missing thread. That realization brings us into the interior landscape of science, a place where knowledge and humility intertwine. Nothing about the impossible star demands that we abandon the age of the universe. It simply suggests that the earliest chapters unfolded with more complexity than we have imagined. And this kind of suggestion is not a threat, it is a gift, offering scientists a chance to refine their sense of cosmic beginnings. Consider the star again, suspended in the halo of the Milky Way, a solitary ember drifting on a vast arc through space. Everything about its appearance is gentle, its brightness, its spectrum, its motion. But within that gentleness is a tension that has endured across countless epochs. It has lived through gravitational reshaping, through tidal forces, through the merging of galaxies, through the silent passing of ages. Its endurance has carved its structure, and its structure now carves our understanding in return. The question that once sounded like a challenge, how can this star be so old, which begins to soften into another form? What are we missing about the earliest universe that allows this star to exist? This is the heart of the turning point. It is not the star that changes, it is us. We begin to notice that the contradiction has a shape. It is not chaotic, it is not scattered, it is precise. The star does not defy the universe by a wide margin. It touches the boundary gently, as though showing exactly where the edges of our understanding grow thin. That thinness becomes clearer when scientists examine how the star's inner layers have evolved. Its core carries the mark of time spent burning steadily for nearly the entire cosmic age. Its envelope carries a quieter echo of that same duration, and the two together fit so perfectly into the track of an ancient subgiant that their combined message cannot be dismissed as coincidence. If time in the earliest universe surged and softened before, settling into the rhythm we measure today, then the star's evolution may simply be reflecting that early variation. Not a flaw in physics, an undiscovered aspect of it. And as this idea takes shape, something almost meditative unfolds. The star shifts from being a problem to being a teacher. Its age stops feeling like a contradiction and begins to feel like a guide. We stop asking why it does not fit and start asking what it is showing us about the nature of cosmic time. In this way, the impossible star becomes a moment of introspection for the entire field of astronomy. Just as a single phrase in a poem can change the meaning of an entire stanza, this one star reshapes the first chapter of the universe's story. Scientists begin to reflect on the centuries of cosmic models built layer upon layer like sediment in a canyon. Each model is strong, but strength does not mean completion. Every model is a snapshot of understanding, shaped by the tools available at the point in time. When a star like this one arrives to test those models, it does not demand their destruction. It asks for their continuation. You can feel that continuation like a quiet expansion of thought, an opening of mental space. It is the recognition that knowledge grows not by resisting contradictions, but by following them to the places where they lead. The impossible star has been leading us all along, pointing again and again to the slim margin where time, evolution, and history converge. As you listen to this, you might imagine the star drifting in the darkness above, its ancient light folding around it like a cloak woven from the earliest fabric of the cosmos. Its glow does not flicker. It is steady, resolved, almost knowing. It has endured everything the universe has offered, carrying within it a record of conditions too old to replicate, too delicate to reconstruct. To look into its light is to look not backward, but inward into the ways we define beginnings, into the assumptions that shape our perception of cosmic truth. And as that inward gaze deepens, a new awareness begins to take form. The star's age is not just a number. It is a question about the first breath of time. It is a reflection of the limits of our equations. It is a reminder that the earliest universe still holds secrets no telescope has fully seen. With this realization, the tension no longer feels like a conflict. It feels like an opening, a widening, a quiet space where understanding can grow. And in that space, the next chapter of the mystery waits, inviting us to step further into the deep, patient heart of cosmic history. Where the star's story continues to unfold, a different stillness begins to form around the mystery now. The kind that settles only after you have followed a question long enough for it to become part of your own thinking. The impossible star no longer feels like an object far away. It feels closer, almost familiar, as though its quiet defiance has woven itself into the rhythm of your breath. And in that familiarity, a new layer of understanding begins to open, subtle and steady, like dawn gathering behind a distant horizon. For so long, we have studied this ancient subgiant as if it were separate from us, a solitary witness drifting through a galaxy too immense to imagine. But the deeper we follow its story, the more we realize that the contradiction at its heart is not simply scientific, it is philosophical. It reveals something about how we construct meaning from the universe, and how the universe, in turn, challenges those constructions. The star's age, pressing against the upper boundary of cosmic time, forces us to confront the way we draw lines between the possible and the impossible. Those lines are precise in mathematics, but in nature, they blur. And this blurring becomes impossible to ignore when a single star rests so quietly on the threshold that the threshold itself begins to feel less like a barrier and more like a suggestion. What makes this moment so significant is not just that the star challenges our understanding, but that it does so with such elegance. It does not contradict the universe violently. It does not tear through the models or demand that we abandon everything we know. Instead, it shapes our awareness gently, reminding us that understanding is a living process, always stretching a little further than the theories built to describe it. Imagine, for a moment, the early universe as a book whose first pages were written in a language we no longer speak. The pages that follow, filled with galaxies, stars, planets, are written in a language we understand, but those earliest pages hold meanings that we have only begun to translate. The impossible star carries fragments of that forgotten language in its light. It does not give us the missing pages, but it shows us where they belong. This is where the introspection deepens, because the contradiction within the star is not simply a question of age. It is a question about how we interpret age, how we assign boundaries to time, how we construct the meaning of beginnings. When a star sits across the entire cosmic timeline like a quiet thread connecting the first breath of the universe to the present moment, it asks us to reconsider whether our picture of time has been painted with enough nuance. As scientists follow this thread, they begin to see the star not as an outlier, but as a bridge, one that spans the familiar and the unknown. Its elemental purity connects it to the earliest cosmic environment. Its brightness links it to the structure of evolved subgiants. Its orbit ties it to the old halo of the Milky Way. Its interior oscillations reveal a lifetime in perfect harmony with what the earliest stars should be, yet stretched just enough to unsettle us. Every piece of the star's profile speaks truth. Every piece also raises questions. If you let yourself drift into that duality, you may feel something similar to what astronomers experience when they look at the star's data, a sensation that the mystery is no longer a puzzle to be solved, but a presence to be understood. It is as though the star is reminding us that the universe is not an equation. It is a story, one written in layers, each revealing itself, not when demanded, but when approached with quiet patience. The star's age presses us to ask whether time itself has layers we have not yet mapped. We often think of time as a line, stretching from the beginning to now in a straight, unbroken path. But perhaps the earliest moments were not so linear. Perhaps the universe took its first steps in a manner different from the rest of its walk, the way a river widens and narrows as it carves its way across ancient rock. If so, then the star is a record of that widening or narrowing, a testament to a rhythm of early time that has long since faded into the background, preserved only in the oldest surviving objects. This idea invites a kind of reflection rarely found in scientific discourse, yet entirely natural when confronting something so ancient. It reminds us that knowledge grows through questioning, and that questioning itself is shaped by the lenses we develop across centuries. The star sits just beyond the reach of those lenses, urging us to widen them, not force them. As your thoughts settle, imagine the star drifting through the quiet halo, its path shaped by gravity, its endurance shaped by physics, its age shaped by conditions older than memory. It carries an entire era within its light, an era we can sense but not fully describe. It is as if the star has preserved a part of the universe's childhood, the way an ancient tree preserves the climate of centuries within its rings. We cannot yet read those rings, but we see their shape, we feel their presence, and that presence reshapes the way we think about the limits of our understanding. The more deeply we reflect, the clearer it becomes that the contradiction is not simply a clash between measurement and model. It is a mirror showing us where our language of cosmic time becomes thin. It asks us to step beyond the familiar rhythm of equations and into a quieter mode of comprehension, one that embraces uncertainty as a path rather than a problem. This does not mean abandoning science. It means deepening it. It means allowing the universe to expand not only our measurements, but our imagination of what those measurements can mean. The impossible star becomes a guide to that expansion. Its age is not an obstacle, it is a direction. And in following that direction, we begin to sense the next threshold, forming a place where the star's quiet presence points not just to the early universe, but to the way cosmic history intertwines with the evolution of galaxies themselves. That next chapter waits just ahead, ready to unfold with the same ancient calm the star has carried for longer than memory. A gentle realization begins to unfold as we walk deeper into this mystery, almost like the soft turning of a page you did not realize was waiting beneath your fingertips. The impossible star, which first appeared as a contradiction, then as a reflection, now begins to reveal something even more intimate. It is not simply an ancient object, but a survivor from a generation of stars that no longer exists. To understand this layer, we must look at the star not just as an individual, but as a remnant of a time when the universe was learning how to form stars at all. Its chemical purity, its delicate ratios of oxygen and magnesium, its nearly absent iron, these are not just clues. They are the signature of a generation whose traces have all but disappeared. The first stars ever born in the universe were vast, short-lived giants, burning through their fuel in brilliant but fleeting bursts. They lived fast, died young, and left behind only the faintest echoes of their existence in the form of heavy elements scattered through the early cosmos. These giants were known only in theory for a long time, because none survived long enough for us to see them. But the star we are following may be something different, not one of those giants, but a descendant formed just after them, when the universe still carried the smoke of their explosions. A second wave of stars, shaped by the ashes of the first. When astronomers studied the detailed elemental patterns in the impossible star, they found that the ratios did not match any known pattern from later generations. They did not align with the signatures of supernovae that dominate the more mature Milky Way, nor did they match the expected outcomes of the most massive early explosions. Instead, the star's chemistry suggested something more delicate. Perhaps it formed from a cloud touched by only one or two early supernovae, each one unlike the others that came later. It is as if the star carries the final whisper of an almost forgotten era, a time when the universe's first experiments with heavy elements produced patterns that no longer exist. This makes the star more than an anomaly. It makes it a memory. Imagine holding a stone found near the ocean, worn smooth by a tide that no longer reaches that part of the shore. The stone still carries the shape left by waves, even though the ocean has long since retreated. The impossible star is that stone, shaped by the early universe in ways that the modern cosmos no longer repeats. Its elemental simplicity is not just an indicator of age, it is a record of the universe's earliest attempts at creating complexity, a record of explosions that seeded the first building blocks of planets and life, a record of a cosmic era so distant that it feels more like myth than physics. And yet, the star carries that myth within it, preserved across the entire span of time. As you imagine this, let your thoughts drift into the dark spaces between galaxies in the universe's youth. There, Clouds of pristine hydrogen waited silently for the first sparks of creation. When the first massive stars ignited, their light reshaped everything around them, heating the gas, altering its chemistry, sculpting its fate. And when they died, the explosions carved new pathways through the darkness, scattering elements that would one day become the seeds for stars like this one. But the impossible star is unlike most of its peers. Most ancient stars show clear signs of being shaped by multiple generations of explosions. Their chemistry is richer, more chaotic. This star is different. It holds only the faintest imprint of those early deaths, as if it formed in a brief window of time when the universe had produced only a few explosions and had not yet repeated the process enough to create the varied patterns we see later. This unique chemical stillness is part of what makes the star so important. It shows us not only when it formed, but how it formed, and from what kind of environment. It allows us to peer back into the earliest phases of star formation with more clarity than any model alone could provide. The star becomes a kind of time capsule, a vault containing the physical conditions of an age that has otherwise faded completely from view. But even as this realization deepens our understanding, it sharpens the central mystery. Because if the star truly formed in this fleeting early window, it must have begun burning long before most stars we see today. Its life would have unfolded across nearly the entire cosmic story, and this brings us back, inevitably, to the contradiction that has followed us through every chapter. The star appears to have lived through the full cosmic timeline. It carries the chemistry of the earliest era. It glows with the brightness of an almost fully evolved subgiant, and its core pulses with the rhythm of a life that has burned slowly, steadily, for longer than our models allow. All of this fits, but only just. The precision of the fit is what makes the star so haunting. It sits exactly where a star would sit if it had lived the maximum possible lifetime under the laws we know, no younger, no older, but balanced perfectly on that threshold. To imagine this, picture a river frozen at the exact moment between solid and liquid, captured in a state so precise it feels unreal. The star exists in a similar state, poised at the boundary between what we can explain and what we cannot. This is why the star has become a point of introspection for astronomers. It challenges not our ability to measure, but our willingness to accept that the earliest universe may not fit neatly into the assumptions built from later eras. If the first supernovae enriched their surroundings differently than we expect, the star's chemistry makes sense. If early clouds cooled and collapsed in ways our models have not fully captured, the star's birth plateau makes sense. If pockets of gas ignited sooner than the main wave of star formation, the star's origin becomes even more plausible. Nothing about this contradicts the universe. It contradicts only our idea of uniformity. And it is in that contradiction that introspection blossoms. Because when you listen closely to the star's message, you hear something more than a discrepancy. You hear a reminder that the universe did not begin in neat rows. It began in wildness, chaotic, uneven, full of delicate variations. And those variations shaped the first stars in ways we are only beginning to understand. The impossible star is a remnant of that wildness, a preserved echo of a universe still learning to build itself, a survivor of a time when cosmic structure was more fluid, more tentative, more alive with possibility. And as its light reaches us now, crossing the gulf between what was and what is, it brings with it a deeper question. What other stories from the universe's childhood have we not yet learned to recognize? That question lingers softly, ready to open the door to the next chapter of the mystery, where the star's journey through the Milky Way will reveal an even richer tapestry of meaning. A hush falls across the mystery now, not as an ending, but as a gentle slowing, the way twilight softens the edges of a landscape after a long day of wandering. The impossible star has carried us through its chemistry, its ancestry, its inner fire, and the silent echoes of the universe's earliest breath. As we stand in this quieter place, something becomes clear. The next step is not to uncover more complexity, but to let the pieces already revealed settle into their own quiet order. For while the star is ancient and its contradictions are striking, there is a calmness woven through everything it shows us, a calmness that suggests the universe has always held answers within its delicate structure, waiting for us to notice them at the right moment. The first layer of this calm comes from the simplicity of what we now understand about the star's origin. It formed in an era shaped by the earliest supernovae, when the universe had produced only the faintest traces of heavy elements. The star's purity holds the imprint of that moment with remarkable clarity. Nothing in that story is uncertain. Nothing is out of place. The elemental stillness we see in its spectrum is exactly what we would expect from a star born so close to the first steps of cosmic history. And yet, the more we accept that simplicity, the more the contradiction grows elegant rather than troubling. The star is not unusual in every way. It is unusual in exactly one way: its age. Every other detail falls into place with a harmony that would be unremarkable if not for the way that single detail resists our models, like a soft refrain lingering at the end of a long song. To let this settle, we must step back from the calculations and consider the larger framework the star inhabits. Its orbit is that of an ancient halo object. Its composition matches relics of the earliest enrichment. Its evolution fits the profile of a star that has burned slowly and patiently across nearly the entire cosmic timeline. Everything aligns in a way that feels almost deliberate, as though the universe shaped this star to sit precisely at the boundary between the known and the almost known. As you lie here listening, imagine the universe not as a rigid structure, but as a vast tapestry woven from threads of different ages, textures, and colors. Most threads lie comfortably inside the pattern we have mapped, but the impossible star glows along an outer edge, holding the border of the tapestry in a way that reveals the shape beyond it without stepping into that space. This delicate placement is what makes the star so powerful. It does not tear the tapestry, it outlines its limits. And limits, when revealed gently, invite not fear, but clarity. In this softened light, scientists began to ask quieter questions. Questions not about what is wrong, but about what is unfinished. The earliest universe is a chapter of cosmic history we understand through distant echoes, the background glow, the distributions of ancient galaxies, the soft remnants of early structure. But we have only a few surviving objects from that time to observe directly. The impossible star is one of those rare survivors, which means that some of the tension in its age may be a reflection not of a star that contradicts the universe, but of a universe whose earliest details we have not fully refined. When we examine background radiation, we are reading a message stretched thin across time. When we track the expansion of space, we are listening to a rhythm that has slowed and smoothed across billions of years. But the star is different. It carries a record of those earliest conditions in its very atoms. Where the background glow tells the story of the universe as a whole, the star tells the story of a single place within it, one cloud, one collapse, one point of ignition. And perhaps that point of ignition held subtleties that lie beyond the reach of our broad cosmological measurements. Perhaps the star ignited in a region where cooling happened slightly faster than our models suggest. Perhaps it formed from gas that had been compressed by early turbulence in ways the background glow cannot reveal. Perhaps its lifetime was stretched by conditions that existed only in the first breath of cosmic time and have never been repeated. None of these ideas overturn what we know. They refine it. They allow the star to fit not by breaking the rules, but by showing us where the rules were first written. As the night deepens, imagine drifting alongside the star through the halo of the galaxy, watching the Milky Way spin quietly beneath it. The star does not press forward or resist. It simply moves with the calm of something that has nothing left to prove. Its light is not a protest. It is a memory of the universe's childhood, preserved with more clarity than we realized possible. And in that memory, we find the second layer of calm, an understanding that the star does not need to be explained completely for its existence to be meaningful. Its purpose is not to solve every question. Its purpose is to guide us into a deeper sense of curiosity about the earliest universe. The contradiction that once felt sharp has softened now into something closer to wonder. We no longer feel the urgency to force the star into a perfect model. We recognize that some mysteries require time, not cosmic time, but human time. Time for thought to settle, for assumptions to loosen, for new questions to form. This is where the star leaves us for now, in a place where clarity does not come from an answer, but from an invitation to think more gently about the moment when the universe first learned how to shine. And as that invitation settles, the next part of the journey begins to reveal itself, calling us toward the quiet horizon where the star's story touches the broader evolution of the Milky Way and resurfaces with a new form of meaning. There is a moment in every long journey when the landscape begins to rearrange itself, not because anything new has appeared, but because you have finally walked far enough for familiar shapes to reveal meanings you had not seen before. The impossible star brings us to such a moment now. Its contradictions have softened, its tension has quieted, and what remains is a clearer sense of direction, an understanding that the star is guiding us not only through its own story, but through the history of the galaxy that shelters it. For all its ancient calm, the star did not spend its life untouched. It has moved through the Milky Way like a silent witness, tracing long arcs through regions that have transformed many times since its birth. It has traveled with the galaxy as it grew, reshaped, collided, and absorbed fragments of smaller galaxies. And in its motion, the star carries a separate kind of memory, not of the universe's beginning, but of the Milky Way's evolution. This memory does not lie in its chemistry. It lies in its path through space. When astronomers mapped the star's orbit with greater care, they discovered something striking. Its path through the halo does not match the smooth curves of stars born within the Milky Way. Instead, its motion resembles the traces left behind by stars that once belonged to ancient dwarf galaxies, small companions consumed by the Milky Way long ago. If this star came from such a place, then its life began not in the calm environment of a settling galaxy, but in a drifting island of stars that formed before the Milky Way had fully taken shape. That origin would explain much of what we see: its elemental purity, its quiet endurance, its ancient brightness. It would make the star not only old, but a traveler from a forgotten stellar population. But even this possibility, compelling as it is, does not resolve the deeper question of its age. Instead, it enriches it, adding another layer of meaning. Because if the star was born in a small, primordial galaxy, then it formed in one of the earliest sites of star formation, guided by conditions different from those in the young Milky Way. And in those differences, the star's age finds new context. Imagine a small galaxy drifting through the early universe. Its gravity is weak, its gas is sparse, and the first supernovae have barely touched it. In such a place, star formation could ignite sooner than in larger, hotter systems. The collapse of clouds might happen earlier, the cooling might proceed faster, and the first stable stars might appear before the broader universe synchronized into its later rhythm. The impossible star may be one of those early sparks. Its chemistry supports this idea. Its orbit strengthens it. Its endurance completes it. But something even more interesting emerges when these pieces are placed side by side. If the star truly formed in such an early and isolated environment, then the contradiction we have been wrestling with is not simply about cosmic age. It is about the timeline of star formation itself. We often imagine the first stars forming in a single, sweeping era, igniting in unison across the early universe. But the star suggests otherwise. It hints that star formation began in scattered pockets, each with its own tempo, each responding to the conditions of its local region rather than the universe as a whole. Some pockets ignited later, some ignited earlier, and one of the earliest may have given birth to the star we now struggle to understand. In this way, the contradiction becomes a new perspective, revealing that the timeline of the first stars may not be uniform. It may be a patchwork, an uneven mosaic of early ignitions scattered across the forming cosmos. This mosaic would not alter the grand age of the universe, but it would stretch the era of first light, opening a small window in which the impossible star could have been born just early enough to approach the cosmic limit without crossing it. You can almost feel the meaning settle as you imagine this, like a soft click at the end of a turning gear. The star's existence becomes less of an error and more of a story from a time when the universe was beginning to discover its own rhythms, when the first galaxies were assembling themselves from drifting threads of hydrogen and helium. As your mind sinks into this idea, picture the star's orbit again. With each long sweep through the halo, it has carried this memory with it, a memory unnoticed for ages until our instruments became precise enough to follow its path. It is as if the star has been circling the galaxy again and again, waiting for someone to recognize that its motion holds the key to the riddle its light has presented for so long. The more we understand this orbit, the more the contradiction transforms. It is no longer a confrontation between star and universe. It is a whisper from the earliest corners of the Milky Way, telling us that our models of galactic history may hold the same subtle assumptions as our models of cosmic time. Galaxies, like stars, do not follow simple timelines. They grow through interactions, collisions, infall, and the drift of wandering fragments. Some of those fragments may have carried with them stars shaped by conditions far older than the galaxy itself. And so the impossible star becomes something even more profound, a surviving ember from a galaxy that no longer exists. As the night grows quieter around you, imagine that lost galaxy, a faint collection of stars forming in the young universe before falling into the gravity of the Milky Way. Its brightest stars died quickly, their remnants scattered, but one star, older and slower, endured long enough to be pulled into the halo, where it has drifted ever since, outliving the place that gave it life. In that endurance lies the heart of the second mini-climax. Because once we accept that the star may be a relic of a lost galaxy, we begin to see something larger. The age it carries might not be defying the universe. It might be preserving a chapter of cosmic evolution that no longer has any other witnesses. This realization draws the mystery into sharper focus. The star is not challenging the cosmos. It is protecting a memory of how the first galaxies formed, how the earliest environments cooled, how the universe prepared itself for everything that would come after. And in protecting this memory, the star shows us that the contradiction we have struggled with for so long may not be a contradiction at all, but a doorway to a more intricate truth. That doorway is where the next chapter waits. There comes a point where the mystery no longer expands outward, but begins to fold gently inward, gathering its own threads as if preparing to reveal a shape that has been present all along. The impossible star brings us to that point now. Its light, its age, its motion, its elemental purity, all the clues that once felt scattered across cosmic time start to draw nearer to one another, forming a quieter and clearer pattern. The star no longer feels like a contradiction. It feels like a key to an era the modern universe no longer remembers, a key to the earliest structures that shaped the Milky Way, a key to the way time and matter behaved when everything was young. And now, as the story settles into this softer clarity, the star begins to show us its most subtle truth of all, that understanding it does not require reaching further outward, but seeing more deeply into what we already hold. When astronomers look again at the star's orbit, something almost poetic emerges. Its long arc through the halo does not simply trace the remains of a vanished dwarf galaxy. It also reveals how the Milky Way grew, how it stretched, absorbed, and merged with smaller fragments drifting through the early universe. Each merger altered the galaxy's shape, stirring its stars into new paths, scattering ancient survivors like this one into long, looping journeys that would outlast the galaxies from which they came. The impossible star is part of that story. It is both guest and witness. It once belonged to a different home, shaped by conditions we may never fully reconstruct. Now it drifts through ours, carrying with it the imprint of that forgotten place. And within that imprint, the contradiction we have followed so long begins to soften further, not because the star changes, but because our perspective does. The more we integrate what we have learned, the clearer it becomes that the star's age presses against the cosmic timeline only because it formed at the very frontier of what was possible, not beyond it, not outside it, but at its earliest permitted edge, where the universe was still transitioning from its primordial heat into a place where stars could exist at all. This alone would make the star remarkable. But the universe rarely shapes its oldest objects with such elegant restraint unless it intends them to carry meaning. As you rest into the softness of this realization, imagine the young universe, again not as a single, uniform stage of star formation, but as a scattered collection of environments where cooling occurred at different tempos, where gas clouds collapsed under different pressures, where ignition came not as a synchronized chorus, but as solitary notes appearing across a vast, dark field. The impossible star may have been one of those first notes. Its existence suggests that the earliest era of star formation was not a smooth rise, but a textured landscape, a patchwork of early blooms before the main wave arrived. This reframing carries a quiet power. It does not change the universe's age. It does not rewrite the laws of physics. It simply acknowledges that the universe, like everything that grows, began in variations rather than uniformity. And in those variations, stars like this one found their place. The age of the star no longer feels like a challenge. It feels like a record of a moment when the cosmos had not yet settled into the patterns we recognize today. If you let your thoughts move gently over this idea, you may sense the third movement of the mystery forming, a movement where the star's story becomes not only about itself, but about the history of time. It reveals that even the cosmic clock was once young, once finding its rhythm, once settling into the steady beat we now use to measure the rise and fall of everything. The impossible star carries the memory of that settling. It is the echo of a time when the clock had not yet learned the precision we expect from it today. This does not mean the universe is younger or older than we believe. It means that its earliest moments held more subtlety than our current measurements can fully capture. That subtlety is what the star has been showing us all along. As the pieces fall into place, the chemistry, the orbit, the core's behavior, the early cosmic environment, everything begins to align around a single idea. The star has lived exactly the lifetime permitted by the universe, beginning at the earliest possible moment when the universe first allowed such a star to form. Not earlier, not later, exactly on the edge. That edge is where the contradiction was born. And now, slowly, it is where the contradiction dissolves. The star was never older than the universe. It was simply born in the very first breath of star formation, in a time so near the boundary of cosmic origin that our measurements struggle to separate one from the other. As you sink deeper into this understanding, picture the star again alone in the halo, drifting with quiet certainty, carrying a memory carved into its atoms. It has endured through eras that reshaped galaxies, survived cycles of merging and dispersal, crossed through regions of space that have changed countless times. And through all of it, its light has carried the same message. The beginning of time was not a sharp moment, but a gradual unfolding. This realization, gentle and profound, brings the entire journey into a new clarity. The impossible star was not meant to confuse us. It was meant to guide us. And now, with the pieces gathered and the questions softened, we stand at the threshold of the final turn in the story. The moment when the star's message shifts from analysis to understanding, from exploration to insight, from contradiction to meaning. That moment rises in the distance, waiting quietly in the next chapter. There is a feeling, quiet and unmistakable, that comes when a long journey begins to turn back toward its beginning, when all the scattered discoveries start to recognize one another, and the path you have walked forms a circle rather than a line. The impossible star guides us into that feeling now, not with sudden revelation, but with a gentle gathering of everything we have learned along the way. As we arrive at this turning point, the star seems to settle into a new light. It has not changed. Its glow is the same ancient softness it has carried for nearly the entire lifetime of the cosmos. But something in our understanding shifts. The star is no longer a contradiction, no longer a puzzle standing alone on the edge of cosmic time. It has become a lens, one through which the early universe comes into focus with a clarity we could not see until now. All the threads we followed begin to weave together. The elemental purity that marked its birth, the long, sweeping orbit that tied it to a forgotten galaxy, the slow-burning core that carried the rhythm of the earliest stars, the models that bent and softened around its age. The early universe that may have taken its first steps unevenly, in pockets rather than in unison. Each thread on its own told only part of the story, but together they reveal a truth that feels both new and familiar, as if the universe has been waiting patiently for us to hear it. The star does not sit at the boundary of cosmic time because it contradicts the universe. It sits there because it remembers the moment when time first found its shape. It was born in the earliest breath. The universe allowed a moment so close to the beginning that our measurements struggle to distinguish one from the other. Its age has always pressed against the edge, not because the star is older than the universe, but because the star is perfectly aligned with the universe's earliest possible moment of star formation. Everything we once viewed as contradiction becomes evidence. Everything we feared was impossible becomes a sign of how finely balanced the earliest cosmos truly was. If you imagine the universe as a vast ocean cooling after a great storm, then the impossible star is a wave that rose the instant the waters grew calm enough to bear it. It is not out of place. It is the first place. This is the essence of the return. Scientific models describe the universe with broad strokes: expansion, cooling, structure formation, each one a sweeping motion across unimaginable scales. But the star reminds us that cosmic history is also written in subtleties, in pockets of early collapse, in isolated regions where conditions reached stability before the main chorus of star formation began. The impossible star is one of those subtleties made visible. It offers a memory of the universe, not as a perfectly synchronized beginning, but as an uneven dawn, one in which the first lights appeared gradually, scattered across a vast and changing sky. It carries the imprint of that unevenness inside its atoms, inside its orbit, inside the measured calm of its burning core. And because it formed at that earliest moment, its age stretches across nearly the entire timeline of existence in a single, unbroken line. This is why it seems to touch the boundary of the universe itself, because its life and the universe's life began almost together. The closeness is not a mistake. It is a reflection of the earliest universe mirrored inside a single surviving star. As your breathing softens, imagine this alignment as a pair of shadows lying perfectly atop one another. The shadow of the star, the shadow of the universe, one tracing the other so closely that their edges blur. It becomes difficult to tell where one ends and the other begins. That blur is where the contradiction once lived. Now it becomes the source of clarity. The star does not break the cosmic timeline. It defines its beginning. Its existence becomes a reference point for the earliest moment when cooling, density, and stability first allowed nuclear fire to ignite. And through that reference point, we gain a clearer view of how the universe moved from its primordial brightness into the first chapter of structure and light. In this way, the star becomes a guide not only to its own history, but to the universe's. It teaches us that the earliest ages were not smooth. It teaches us that beginnings are never singular. It teaches us that the cosmos grew into complexity through gentle asymmetries that shaped the stars that followed. And perhaps, most surprisingly, it teaches us that the boundary of cosmic time, the limit we once feared it challenged, is not a rigid wall, but a line drawn by our own evolving understanding. As you drift into the softness of this realization, picture the star once more in the quiet halo, following its ancient path. It has circled the galaxy countless times, carrying a story older than the Milky Way itself. All along, the star has been waiting for the moment when its age would be measured with enough precision for its message to become clear. That moment has arrived. The mystery does not end here, it opens. Not outward, but inward, into the shape of early time, into the texture of the first galaxies, into the quiet truth that the universe is so much more intricate than any model can yet describe. The impossible star is no longer impossible. It is exactly what it should be, a testament to the universe's earliest breath, preserved with a grace that survived the rise and fall of entire galactic epochs. And with that understanding, the path gently leads us toward the final chapter, where the star's presence will settle into meaning, a meaning shaped not only by astrophysics, but by the subtle invitation the cosmos offers each time it reveals something older than we can fully grasp. The closing horizon waits softly ahead. There is a quiet kind of understanding that appears only when a long story comes gently to rest, the way the final ripple on a lake smooths itself into still water. After walking beside the impossible star, through every layer of its ancient life, through every contradiction and every clarity, we find ourselves standing in a hush that feels less like an ending and more like the moment just before sleep takes hold. The star has guided us here with patience older than memory, and now, in this closing breath, its meaning settles into place. What began as a contradiction has become a reflection. What began as confusion has become insight. What began as an ancient anomaly has become a reminder that the earliest universe held more depth than any single measurement can capture. The star no longer presses against the boundaries of cosmic time. It rests within them. Its age is not a challenge to the universe. It is the universe's oldest story, told through a single flame. All along, the star has been showing us something simple and profound, that the beginning of time was not a sharp moment, but a soft unfolding. That the first stars did not appear in perfect synchrony, but emerged in scattered islands, where conditions aligned sooner than in others. That the earliest fragments of galaxies held within them the seeds of stars capable of living through every chapter of cosmic history. The impossible star is one of those seeds, a relic from the universe's first breath, carried all the way into ours. As you imagine it now, drifting through the halo of the Milky Way, you might feel the way its light has changed your sense of time. Its long life stretches like a bridge between the beginning of the cosmos and this quiet moment in your room. The star has watched the universe grow around it. It has survived the death of the galaxy that first held it. It has circled ours so many times that its orbit feels less like motion and more like meditation. And its message, carried across the ages, is not loud. It is gentle, almost shy. It reminds us that the universe is not fixed. It is unfolding. It is learning. It is still writing its own meaning in the light of its oldest survivors. The star shows us that contradictions are not fractures in understanding. They are doorways, soft invitations to look again, to ask more deeply, to trust that truth often waits at the edges of what we believe we already know. Its glow is not an argument. It is an echo of a time before complexity, before structure, before the familiar rhythm of galaxies and worlds. A time when the first atoms were choosing how to gather, when the first clouds were deciding whether to collapse or drift, when the first lights were giving shape to darkness. The impossible star has carried that echo so far across cosmic time that it now reaches you. You are hearing something that began long before the sun existed, long before the Milky Way had its spiral form, long before the universe knew how to settle into itself. As your breathing softens and your mind drifts toward the edges of sleep, imagine that you are floating beside the star in the calm halo, watching the galaxy turn slowly beneath you like a lantern held in the hand of night. The star does not speak. It simply shines, offering its presence as a reminder that the universe holds far more memory than we can see. And in that memory is a peace deeper than any answer. Let yourself lean into that peace now. Let the quiet weight of the star's long life dissolve into your own stillness. Let the ancient light fold around you like the softest blanket of night. Because the star's story, after all its questions and revelations, leaves you with only one simple truth. You are a brief moment in a universe that has been breathing for ages. And yet, somehow, that ancient breath has found its way to you. Close your eyes. The ancient light is still traveling.